So welcome everybody to the 2025 Marine Conservation and Policy Program Symposium. I'm very sorry that I'm only there in 2D, but my incredibly beautiful 2.5-year-old granddaughter Lily, who normally lives in DC, is here visiting my wife and and she invited me to breakfast. I just want to say you're an incredibly close second this morning, but I'll be here virtually. Anyway, this is a very exciting and very important event as we all listen to and celebrate your achievements with your projects in the past year. This is, of course, my favorite SoMAS event of the year since in part because as being a marine science student myself, I always learn a great deal. I'm making progress. Not quite at your level yet, but I'm making progress. But I love to hear about the great breadth of the work of all of our students, as well as the depths, so to speak, of your individual studies and explorations. I note that this is not the end of your relationship with SoMAS, but only a beginning, as we will always be connected, through the seas. Likely, we will, many of us, continue to inhabit Long Island, and so run into each other, and in many cases, collaborate with you, maybe even work with you in the years to come. It's a small world. When you share a discipline, you see your fellow students who you've made connections with. You'll be connected to them and hopefully to us for the rest of your career. So lucky for SoMAS. Anyway, thanks very much for being SoMAS MCP students. We're very proud of your achievements, and I hope you have fun today. I know that I will. Thanks.
So I think you all know who I am, but for those who may not, I'm Ellen Pikitch, and I've been involved with the MCP program since it started, and have been the faculty director for the last 5 years. It's really been a great pleasure for me over this period of time to see how the program has grown, how it's evolved, it's gotten bigger. Our students have gone on, many of them to get great jobs in their fields, and people do stay connected. And several of the people who serve as advisors and mentors to current students are alumni of the program. So that's, it's just been great watching that happen over the course of all these years. So I want to thank and welcome, especially the graduating students. I know you've worked really hard, and today's your big day. It's also my big day for a lot of reasons. One is, again, it's my favorite day of the year. To see the culmination of all the hard work that you've done, concisely and beautifully presented to all of us. I can't wait to hear what you have to say. And thanks to the other students, faculty, mentors who have made it to come and listen to the group. Okay. I did also want to share that as of September 1, I will be stepping down from the directorship of the MCP program. This is motivated in large measure by my having gotten a large donation, which will enable me to focus much more on international policy and innovative technology work. But I will not be disappearing from the program. I still will be mentoring students. I'll still serve on the MCP steering committee, and I will still be teaching MAR 507. So I'll be around. And Caitlin will serve as the interim director. I know the program will thrive under her leadership. We've worked together for many years, and she is just a gem and knows the ins and outs of the program. So the program will be in very capable hands. Okay, so without further ado, let's get started. Bini, and her title of her talk is Environmental Conservation Documentary Production. Her mentor is Carl Safina. I know Carl is not able to be with us today. He is in Africa, and he sends his regrets. Also, Maddie's internship supervisor, Katie Schuler from Coral and Oak Studios. Is she here? No. Okay. Right. And Caitlin's going to keep track of time.
So for everyone who's presenting today, I'll be sitting third row. I'm going to wave my hand when you're at like 8 minutes. I'm going to stand up at 10, and at 12, I might just start walking towards you. Otherwise, we won't have time for questions.
Good morning, everyone. It's good to see you all again. My name is Maddie Bini, and today I'm going to be talking about my summer internship experience working as a production assistant for a nature docuseries titled In Her Nature. This project is really near and dear to my heart because I've always grown up being very fond of documentary filmmaking, and I really feel like I've been able to make a meaningful contribution to a really inspiring and passionate production team that is making a project that is so much bigger than themselves and what the rest of us are looking at. So I'm going to jump in and kind of start talking about what the show is as a whole before I talk about what I did. So In Her Nature is a PBS-backed nature documentary series that is created by women for women in nature conservation. Each episode focuses on a women-led wildlife conservation project, and the whole show is run by an incredible all-woman film crew. Season 1 of In Her Nature actually was released earlier this year on PBS. I'm going to have QR codes and stuff at the end, so stay tuned. And the different episodes highlighted wildlife conservation projects like anti-rhino and tiger poaching patrols in Nepal, the reintroduction of critically endangered tortoises in Madagascar, the Great Sloth Census of Costa Rica, and even fighting off mega palm oil corporations out of biodiversity hotspots in Indonesia. So this slide here just shows a couple behind the scenes images as well as a map of all the filming locations for season 1. This picture down at the bottom shows 2 women here that I did most of my communication with for this internship. The woman on the far left is the co-founder and wildlife cinematographer Jocelyn Stokes, and the woman on the far right is our incredible producer and director Katie Schuler. These are some serious powerhouse women, and it was really inspiring being a part of a project that is such a labor of love for them. And it was just an experience that really was unlike anything that I've had before. And it's emotions kind of like these that are why projects like In Her Nature matter so much. For one, women are underrepresented in the professional fields of both science and film. Conservation filmmaking has largely been dominated by a male perspective for many years. And In Her Nature challenges this by putting women at the center of each and every one of their stories. Additionally, media is incredibly influential on the public perspective of conservation issues. And so portraying strong female-led organizations combating global environmental crises can have the potential to shift kind of how we see like conservation heroes. I just have a quick question, show of hands. How many of you guys kind of grew up watching or were inspired by David Attenborough documentaries? So like everyone. Okay. So how many of you can now name a wildlife filmmaker that isn't David Attenborough and that is a woman? Okay. Okay. 1. Good. Well, at the end of this, you can say 2, Jocelyn Stokes and Katie Schuler. But that's kind of the point of this project. And so now we all kind of understand that storytelling is a really incredible tool. It encourages engagement and promotes emotional responses that sometimes just facts and data aren't able to provide. So what did I do in all this? As I mentioned before, season 1 has already been released to the public, but the film industry is infamous for having really high turnaround rates. So we're already in the pre-production process of season 2. I had a couple of different roles as a production assistant, the first of which was assisting in festival plans, where I came up with spreadsheets to kind of better encourage the distribution of season 1 to a wider audience through film festivals. I also conducted subject research for season 2. I'll go a bit more in detail on these 2 roles in a little bit. And recently I actually was just included more in the outreach side of this project. So answering questions, scheduling and attending pre-interviews with potential participants in the project, and really just kind of helping things run smoothly for the team as a whole. I will soon, I think, be helping out find additional funding opportunities for the project, which is really exciting. But for this summer, a lot of my time was spent creating spreadsheets and organizing data and really just making sure things run smoothly. This is just a small chunk of the spreadsheet I made for our film festival strategy. Basically just making sure any piece of information that Katie or Jocelyn or any of the other team members needed for any point of distribution that was written down. Going a bit more into the film festival part of my job, I identified film festivals that aligned with the themes of women's issues, wildlife conservation, and global impact. And then I was able to design festival timelines, submission strategies, budget estimates, and impact goals, as well as just kind of writing down any notes, such as what my recommendations were for what episodes should be submitted to what festivals or anything, really just to kind of make the application process easier for our producers. There were also a couple instances where I was able to submit to film festivals on behalf of the team, which was so scary when I first did it, but it was such an honor that I was given, that I had the trust of Katie and Jocelyn to do so. And it was a really nice learning experience because I got to kind of witness firsthand how strategic distribution plans are sometimes just as important as the production of the film itself. I mean, you can have the best documentary in the world and it won't have any impact if nobody sees it. So, but probably the biggest role that I had in this project was my research and story development for season 2. We are in pre-production, which means that we are now looking for new women-led conservation organizations to feature in future episodes. And it very quickly became my job to go out and find those women. So when I was kind of scanning through potential subjects and characters, I gave myself some guiding questions to make sure they aligned with the themes of this show. Number 1, is the project founded by or led by a woman? Does the project focus on wildlife conservation? Bonus points if it features a specific species that we'd be able to highlight in an episode. Would we be able to successfully document wildlife behavior? This was actually really important because a lot of really critical conservation work happens exclusively in labs, which does not disregard the significance of those projects, but unfortunately that doesn't really make great filmmaking. And then finally, has this project received a lot of coverage already, or is it a relatively new story that could really benefit from some additional visibility? Here. The M part of my MCP internship came when Katie Schuler brought me on board because she was aware of my academic background and she was hoping that I could provide some fresh kind of oceanic perspective for season 2. Season 1 didn't have any episodes catering to marine conservation projects or even filmed near marine ecosystems. So it became my primary responsibility of finding women-led marine conservation projects around the world. These are just a few of the women that I looked into, and it really was so inspiring seeing just the swath of experiences that were going on. We have projects of women leading leatherback sea turtle nest relocations in Mexico, flamingo rehab in Bonaire, blue whale vessel strike research and coral restoration in Indonesia. Really just an inspiring amount of women that I was able to look into, and this very quickly kind of became my favorite part of the job for the whole summer. But of course, as it often goes in science and in film, there were some challenges. The first of which is that unfortunately the In Her Nature team is relatively small, so a lot of us are wearing many hats at the same time and took on a lot of responsibilities that may have been outside their official titles. And because of this small team and kind of limited resources, that makes the planning of film shoots, especially those happening in multiple countries in a relatively short amount of time, very tricky. Another obstacle was political. This past summer, the Trump administration passed a bill that cut $1.1 billion in federal funding to the Corporation of Public Broadcasting, and as a result, PBS, and left projects like this one scrambling for resources and for help, and left massive holes in already very limited funding pools. This was frustrating to see, to say the least, because it kind of demonstrated how political decisions can almost come off as censorship to science communication. Without funding, stories like the ones that In Her Nature is trying to tell can often go unheard and unrecognized, which is very sad to see. I am very lucky because I'm going to be continuing to work as a PA for In Her Nature in the fall, but I can't help but think it's a bit of a shame as to why they're wanting to keep me around, and it's because they are going to need as much help as they can get in the near future trying to find funding to keep the project afloat. But despite the challenges, this internship has already had a very broad impact. This series has made science accessible by telling conservation stories that are relatable and making them public, making them very accessible to the public by using free platforms like pbs.com. I was sure my video might not load. This show also elevated women's voices by showing how their stories and their projects contribute to not only environmental issues, but also societal change. And it inspires audiences by combining kind of storytelling and science to promote, oh, let's see, it's supposed to be here. Oh, okay. And this project can also strengthen global networks by introducing both audiences and the researchers involved in these projects to different conservation organizations that are located all over the world. I'm gonna try one more thing. This is just a brief video. Yeah, it's not gonna work. That was a brief video clip of just our cinematographer giving a little tutorial to one of the crew members on filmmaking. Just a cute little personality video. And then I'm going to leave this up here just kind of as I wrap up in case anyone wants to take pictures or write something down. But this internship was an incredible learning experience for me. I gained a lot of practical skills in research and communication and media strategy, but more importantly, I also learned how storytelling can really drive conservation efforts. I witnessed firsthand how women around the world are actively making change, often against massive odds, and how amplifying those voices can really have a significant impact. So what's next, right? The interesting thing about this internship is that I don't really have any results to give you. There's not much data. There's not really an ending. In fact, this show is only kind of just starting to begin. Season 2 is currently in development, so we are looking to tell more stories about even more women in the near future. I will be continuing to work on the show in the fall, assisting in research and strategy planning as best I can, but it definitely is going to be a bit of an uphill battle now with PBS funding being cut. Because of these cuts, projects like this depend more than ever on social partnerships and support. So I'm going to do everything in my power to make sure I continue to do so for the women that I spent my summer working with. If you guys are interested in the project, you can always support them on their Instagram. You can scan those QR codes to watch the episodes for free, and they're not very long, on pbs.com, or you can go on their website. And also, like I mentioned before, we are in pre-production and we are still looking for women conservationists. If you or someone you know happen to be a woman, or if you know a woman who is running a wildlife conservation project, I encourage you to reach out to me via my email. I'd love to look into them and see if they'd be a good fit for the show in the future. I think it would be really cool if in future seasons we could have women that came personally recommended by viewers of the show. But yeah, I think that's about all I've got. Thank you guys so much. Questions? Yes.
That was a great talk. Thank you. In some of the social science literature that looks at the intersection of like social movements, toxics, community health, there is a lot of evidence that women are on the front lines of dealing with community contamination, and sometimes it's tied to things like family health or other types of kind of charismatic, terrible health problems. So although I think some of that literature is convincing, it's not typically tied to sort of the conservation stuff that you're talking about. Do you have a sense of why the filmmakers were involved in this topic to begin with? Like, how did their interests emerge, and Is there any evidence in the conservation literature that would mirror what happens in the toxics literature?
Well, I know the initial founder of the show is this woman here, Jocelyn Stokes. She's been a wildlife filmmaker for many years, and so she reached out to our director and producer, Katie Schuler, and she basically, from what I understand, wanted to create a kind of first of its kind series that amplified like the scientific endeavors of women around the world, especially underrepresented projects. And it's really interesting that you mentioned actually like the social aspects that are often talked about, because that's something that's mentioned in this series as well. A lot of the women that are highlighted for doing their research have significant like social contributions to their community as well. There's a lot of community engagement that goes into all these projects that I honestly haven't really noticed in other shows that are like this. There wasn't a ton of talk about the like toxicity aspect of all that. But I do think there definitely is a tie between women who are running conservation projects having a much stronger kind of relationship with local communities and having the support of their peers and their communities. And they kind of lean on that for support when there's kind of like a lack of representation. Don't know if that answered your question.
Okay, good job. Thank you. Tegan, Castelluccio will be talking about evaluating and comparing lobster pot detection and removal to the lobster bycatch abundance in the Long Island Sound. And her faculty mentor, it's Joe McClanahan. Internship supervisor, Scott Curatolo Wagaman with Cornell Cooperative. Okay, so this will clip onto you.
I do have a pocket.
All right. And go on with the show, Tegan. All right.
Hi. All right. All right. Hi, everyone. My name is Tegan Castelluccio, and today I'll be discussing evaluating and comparing lobster pot detection and removal to the bycatch lobster abundance within the Long Island Sound. Red mouse. Mouse. Okay, so this is my agenda for today. I'll be talking about my internship's background, then move on to the lobster fishery and history on Long Island, move into my project's objective, the methods, results, and the impact this project can have. So I chose to do it with Cornell Cooperative Extension of Suffolk County, specifically the Marine Fisheries Program. Now, CCE Suffolk is a nonprofit community education agency that connects the resources and research of Cornell University to the residents of Suffolk County. Now, the Marine Fisheries Program is an organization on Long Island that collaborates directly with local commercial fishermen. Their mission is to preserve this unique and historical way of life by collaborating with both local, state, and federal managers to ensure sustainable fishing practices. They also assist in designing and testing different conservation gear to reduce bycatch of non-targeted species. Within the Marine Fisheries Program, they have over 14 ongoing projects. However, for the summer, I decided to complete an internship using spatial analysis, using ArcGIS Pro to support their project of derelict lobster trap removal. So in order to understand the project, it's important to understand the history and the reasoning behind this. We used to have a thriving lobster population here within the Long Island Sound. However, over the past decades, it's experienced a significant decline in the population. Scientists believe that it's linked due to environmental stressors and challenges that impact the species. They found that there was a mass die-off event that took place back in 1999, and the population declined by 90%. They found that the environmental stressors were both the rise of increase of temperature of both air and water. There was also a notable find of both increase of freshwater runoff flowing into the sound, and there was also a collaboration of both challenges of human population growth, causing nutrients runoff to flow into the sound, causing hypoxia and other stressors to become this problem. Now, with the thriving lobster population that we used to have a vital fishery that played a crucial role within our economy. However, despite the abrupt decline, there are still long-lasting effects from this vital fishery. A new rising concern comes from this fishery as there is a new accumulation of marine debris that was left behind. And the marine debris specifically that I talk about are lobster traps. Now, lobster traps are and were the primary tool to catch lobsters. There are large rectangular cages that's supposed to follow specific gear restrictions, such as mesh size and vents in place to reduce bycatch and let target species out. These traps sit at the bottom of the sea floor where a fisherman deploys them, and there's a long line attached to them with a buoy to the surface to let boaters and other fishermen know that they're there. These traps are also supposed to have permits attached to the trap to connect the fishermen to their traps that they deployed. However, despite the abrupt decline of lobster mortality and the new growing concern, problems still persist of abandoned or lost traps within the Long Island Sound. These traps are referred to as ghost traps or ghost fishing, which means they still continue to catch and even kill lobsters that get trapped within them and other marine species. So this is where Cornell Cooperative Extension of Suffolk County's Marine Fisheries team initiated a project back in 2010. This project is in partnership to remove abandoned and neglected traps from Long Island Sound. They go out of several different ports within the Long Island Sound, from Northport, Mattatuck, and Mount Sinai. They do this in collaboration with local commercial fishermen to find where these traps are removed, or not from are removed, where these traps are located within the Sound. This problem contributes to the ongoing problems associated with marine debris and ghost fishing. The CCE team has removed over 19,000 lobster traps from the New York waters, and this is equivalent to 950,000 pounds that have been removed. Now, these traps are considered private property, so what the CCE team does is once they remove them, they try to connect the traps to the fishermen that deployed them, but then they end up over the holding period, they turn them into recycled material. Now, this project has been ongoing since 2010, but there hasn't been anything spatially done with the data that has been collected, which led me to my research question for my project. I wanted to see how does the abundance of bycatch lobsters and area for target lobster pot detection and removal vary across years and regions target for removal. How this information improve future removal efforts on Long Island. So for my methods portion of my project, I primarily used ArcGIS Pro and Microsoft Excel to complete my project. This project has been ongoing since 2010 to now. However, I'll only be looking at data from 2010 to 2023, as there was issues with grants and permits at the time of years 2024 and 2025, but I still have an extensive amount of data to look at. Now, I started by organizing their data that was given to me. This data was not organized in a uniform system. Each individual year that the fieldwork was conducted, there was no symbol or symbology throughout them that unified all of them. Even within each individual field location of the year, there was no system that was organized. So after doing that and organizing all that data, I then converted all the longitude and latitude into decimal degrees, and then organized their bycatch data that was collected, focusing specifically on lobsters that were found within these traps. After this, I started to use my ArcGIS tools by inputting all the data sheets into ArcGIS Pro. In my map that I created over here, this is all 19,000 lobster traps that were removed from the Long Island Sound. So how did I got all the points was that I had to convert each of the years of the sheets into X to Y to points. I did this by a bunch of different equations within ArcGIS Pro, but then after getting my points, I then moved on to calculate field equations to add both dead and alive lobsters in numeric form. After this, I then decided to combine both dead and alive lobsters because for the sake of my project, I just wanted to look at the abundance of overall bycaught lobsters found within the Sound. And there was also no way to determine when a lobster was dead or how long they have been dead within these traps. After this, I started to use spatial analysis, spatial statistic, and geostatistical analysis to answer my question. I first performed a hotspot analysis for each individual years using spatial statistic tools. This allowed me to find statistically significant hot and cold spots to refer to locations where lobster bycatch is abundant or lower in regions on Long Island. Within my figure over here, this is my legend that I use for each of my figures I created. The red at the bottom indicate there's a high abundance of bycaught lobsters, where the blue means there's limited or none. The not significant points means that the points that I plotted, there was no bycaught lobsters found within that area. After doing each individual year hotspot analysis, I then used a merge tool to combine all the attribute tables to look at the highest abundance across all the years. So as a result of conducting all these hotspot analysis, I can confirm that bycaught lobsters are being found both dead and alive with a higher concentration near the eastern end of the Long Island Sound. Within my first figure I created, this is a hotspot abundance of lobster bycatch from 2010 to 2023. The top image are all lobsters, both dead and alive combined. The middle are dead lobsters and the bottom are live lobsters. We see from a broad perspective, we see that from Smithtown Bay towards the eastern end of the island, we see there's a high concentration of hotspot clusters meaning that there are high bycaught lobsters being found within the sound. As compared to the western end of the island, we see there's high numbers of not significant points and very limited cold spots and hotspot clusters throughout. This could be due to environmental stressors or factors pushing lobsters towards the eastern end of the island, leading to more bycaught being found in these abandoned or lost traps. We also see there's a significant pattern between each three of the images, that there are no points plotted in the middle portion of this area. This is because this is actually federal navigation channels, so there will be no plots that were put in that area. Within the middle panel, the dead lobsters to live lobsters in the bottom one, we see there's a little bit of a difference between the clusters and the hotspots. We see that for dead lobsters, there's a higher concentration closer to the coast, as for live lobsters, there's a slight upward central location of where they are found. But overall, bycaught lobsters are being found in the eastern end of the island. Moving on to my next figure I created, which is a hotspot analysis of each individual year of live lobster bycatch of the running project. From 2010 to 2023, we see individual field locations and each individual years that this field work was conducted. We see that overall, there are very limited cold spots throughout this project. However, majority of the spots that were recorded are not significant and also hotspot clusters in confidence. But overall, between the two figures I created, it reveals a notable significant shift, or should say a significant geographical shift of lobster bycatch happening within the Long Island Sound. We see that there is less lobster bycatch being found on the western end. Now, the impact this project could have is that it provides a better understanding of where lobsters are more commonly found to protect and further reduce ghost fishing. It also provides a spatial map to include information for future removal projects to see where there's a higher concentration of lobsters to target for future removals of derelict traps. Overall, my two figures I created align with the CCE Marine's fishery team's motivation and mission to raise awareness of marine debris and marine debris accumulation within the sound from this fishery. These maps could be used for their educational websites, pamphlets, or flyers to again raise awareness, but also help for future removal efforts of this project. Now, lastly, I would like to thank my mentor, Scott Wegman at Cornell Cooperative Extension of Suffolk Counties, the Marine Fisheries Department team for allowing me to use such extensive data to complete this project, as well as complete my internship with them. Lastly, I would like to thank my mentor, Dr. McClanahan at SoMAS, for allowing me to be her student during this project, but also for her guidance and mentorship. It would have not been possible without her. So thank you so much. And with that being said, I now open up the floor to questions if there is any. Thank you.
Big question.
Yeah. Hi.
I've always wondered, and I've never gotten a chance to ask this question. How do we find these derelict lobster ponds?
So it is in collaboration with local commercial fishermen to see if they know where any traps have been left behind, or say maybe they even lost traps that from their fishery. The CCE team also does conduct different surveys using side sonar scannings to see where these traps are within the water.
So when you were looking at like those hotspots, forgive me if you've already said it, were you kind of controlling for the number of ghost pots found? Like, so the number of empty pots versus the number of ones that had ones in there?
Yeah, so I took out all their bycatch data because they had an extensive amount of different other species that were collected and recorded. There was also different species between each different field location. So for the sake of my project, I just took out just the lobsters to look at. So I just looked at the empty traps and the lobsters that were found with them though.
And were the areas, sorry, follow-up question.
Go for it.
Was the whole of the sound kind of equally surveyed each year? So I wonder if like the change is based on the change in where they're looking for pots.
So I would say it wasn't. In my second figure that I created, we see that there's some of the years it's a wider field that work that was conducted within that location. They're also running projects. So the year that was listed in the map necessarily wasn't the year that the field was actually conducted or removed. It could be when the grant was issued or permits. So I went off of that year data set. However, some of the fields we see, like the 2023 and the first year, 2010, they were very small concentration of field works that were conducted closer to the western end of the island. So I think that opening up more of a field range to see within the sound would give a better idea to see over time the distribution. Yes.
19,000 pots is an overwhelming
Yes.
of structure. You know, what other impacts do you think that that has on sort of the benthic community, in addition to just ghost fishing for lobster?
It affects like every species there. A lot of times other species are also impacted from it, especially structured species of fish or other species I found within the data they gave me were spider crabs, there were whelks. It was an endless amount of species that can be found with them, especially in each individual field location. I also noticed that as well. So I think it affects everyone, as well as like stuff starts to grow on them and nature starts to retake over these traps that are left behind.
Changes in habitat.
Yeah, entirely, yeah.
Other questions?
Well,
Okay, great job. Okay, Zach Doubek, next. While he's coming up, I will mention his title. Measuring seasonal changes in biodiversity using bottom trawl surveys in the Sedge Island Marine Conservation Zone in Barnegat Bay, New Jersey. David Taylor is a faculty mentor. I don't see David. What?
Joining on Zoom.
And internship supervisor Karen Byrne, New Jersey Department of Environmental Protection. Okay, let's get you.
All right. Good morning, everyone. So yeah, as mentioned, today I'm going to talk about basically how seasonality, I know seasonality may not be the best word because we're just talking about summer here, but how the changing months and seasonality impacts biodiversity in the Barnegat Bay, New Jersey. So a little bit of background here. I completed my internship with the New Jersey Department of Fish and Wildlife. And I have been involved with this organization for 7 years, which is really cool. I'm absolutely in love with the place that I work, which is really, really awesome for me. So I started as a camper. So I completed one of these programs that I'm now a program director for. And I fell in love with not only the content that they taught me, but also the location of the facility. And I knew I had to stay involved. So 2 years as a camper. I then went on and did a 2-year unpaid internship during my undergraduate degree. Basically learning how program directors carry out these programs, all of that kind of stuff. I then followed up with a year of volunteer work until I was hired full-time, and I completed my 3rd year at this time. The good thing about this internship is that every single time that you're out there, it's something new. There's always different challenges we face. There's always new programs being developed. So every year I feel like it's a fresh, not only every year, but every program we want to run is a fresh new idea for me. So I worked as an hourly technician and program director, like mentioned, and this place is called Sedge Island in Barnegat Bay. So what were my responsibilities? Primarily, I was a marine educator, so taking out people, teaching them about the ecosystem, the environment, away from all of like the Jersey Shore houses, which is pretty cool. I also developed programs and worked in coordinating with groups. I assisted with diamondback terrapin research. I trained new interns. I maintained equipment and facility, and I drove participants on our pontoon boat using my captain's license, which is also cool. So here's just a few pictures. As mentioned, my research project was doing trawl work. So this picture on the left is me probably going over some of the species we caught in the trawl net. And then I talked about my diamondback terrapin research. There's me with the diamondback terrapin. So into the research, again, seasonal biodiversity in the Sedge Island Marine Conservation Zone. So while fulfilling all my other duties, I completed this research project with a plan for continued future research. Biodiversity was measured in the Marine Conservation Zone using an otter trawl net. It was about 8-foot opening, so it's not the biggest otter trawl net. And I wasn't using any trawler or any kind of special boat, just a pontoon boat. So I'll show some pictures in a bit. 3 trawls were completed through the summer. So on June 20th, July 8th, and July 24th. I did complete a 4th in early August, but I did not include it for timing purposes. And then data was compiled and biodiversity indices were recorded. And basically I was looking how the biodiversity is going to change. In general, I found some other trawl studies that show that in New Jersey estuaries and the Chesapeake Bay, biodiversity will first increase as the summer moves on, and then in the late summer, it will decline due to higher temperatures and lower dissolved oxygen levels. So this is our trawl net. The great thing about this project is I was actually able to involve staff and participants in my research. So I was able to actually take out some of these groups and help with the trawl. So this is like a high school research camp that came out. So they're learning about my project, and obviously I don't have an A-frame or a winch on my pontoon boat, so they have to haul it and deploy the net. So it's connected to there's 2 cleats on the top of the boat that the rope is connected to. They let it out. I drive the boat in reverse for about 7 minutes. Well, actually, we'll get into that here. So general procedures on each trawl day. 2 trawls were completed during the outgoing tide, 1 in eelgrass and 1 in sandy bottom. So not only are we looking at time, we're also looking at habitat type. For sandy bottoms, I use like a local landmark. So again, I want this study to continue for years to come. So I was very specific in my paper about where the sandy bottom trawl will start and kind of where the boat should be pointed for the duration of the trawl. And then in eelgrass beds, same kind of thing, found that marker, that landmark that could be easily replicated and the direction of the boat. Again, coordinates were provided in the paper. So the net was deployed from the bow of the boat and dragged in reverse for 7 minutes. We didn't want to catch any terrapins or any other organisms that breathe air, and basically just drown them in the net. So only 7 minutes. And then the trawl net was hauled and deployed by hand with staff and participants, as mentioned. So a little bit more into the specifics. Deploying the net. First, I needed my water quality measurements. So temperature and salinity. Both were collected using, well, the state doesn't have the best equipment ever. I'll start with that. So we take a 5-gallon bucket, fill it with water, either drop the thermometer in or use that water sample to put it on a handheld refractometer. And we would record 2 measurements for each temperature and salinity, so 2 bucketfuls. And then I'd average the 2 of them just to make sure that data was accurate. And then I also use the iNavX mobile application to record coordinates. I downloaded a chart that is Sandy Hook to Little Egg Harbor, New Jersey. And I could basically plot a waypoint and give me the exact coordinates of where the boat was at the start of each trawl. Then after hauling in the net, all the contents would be dumped out of the cod end, and then participants and staff would sort through. It's very, very important that we sort through all of the things in the net. There's a lot of organisms that live within the seaweed. And I should clarify that I'm looking at animal biodiversity, so we're not including like seagrasses and stuff like that. And then, yeah, all organisms were identified either using prior knowledge or when necessary field guides. So my results slide, I don't want to spend too much time here. The main thing, I mean, I could go through everything that I caught, but that's not that important for right now. I actually expected to catch a lot more than this, but that's okay. I mainly want to focus on temperature, salinity, and how things are changing. So again, the tide remained consistent, but you can see temperature in June, 23, 24 degrees. Then in July, 27, 20, 28 degrees. And actually a little bit lower in the end of July. But I'm not going to go through all these organisms, but those are the major factors that are going to influence this biodiversity. I did want to highlight some really cool organisms that we did catch. So the first big picture, that is a seahorse, which is super cool. As you can see, the color of the seahorse, you can imagine if you were in the eelgrass beds, which is where that was caught, it wouldn't be the most easy to find that thing. So you really got to pick through everything and then throw it over once you're done. We caught it a little long-finned squid juvenile, which was super cool. The bottom picture is more of like our typical, catch a sea star and a spotfish and blue crabs. So, and then you could see how much seaweed there is on that top left. So it's a lot to go through. So I used all of the hands on deck. So now into the biodiversity indices. So the first thing I looked at was species richness. Species richness is like the very basic form of biodiversity. That's going to be how many species are in each location for each trawl. It doesn't take into account the abundance or anything like that. So for sandy bottom, we can see that it goes trawl day 1, 5, 2, 4, 3, 7. And in the eelgrass beds, it's a little bit higher. Trawl day 1, 7, trawl day 2, 10, trawl day 3, 7. It's kind of easier to see it on the graph here. So if we're just looking at eelgrass beds for species richness, we can see that pattern that I mentioned earlier, that increase and then that decrease. but the same does not hold true for sandy bottom. One thing that's very important to note, and I'll continue to note it throughout my discussion of the biodiversity indices, I only had 3 trawls, which is not a lot of data. So getting statistical significance for any of this is very, very hard. That's part of the reason, setting this up for years to come. It will be better once you get more data, more statistical significance can be gained. So for this, no statistical difference was located between the 2 locations, nor was a statistical significant difference between the total species richness from both locations between days. So yeah, it's only 3 trawls. Again, there was a 4th, but okay. So next, I measured Shannon's diversity index. So what that is just taking species richness and evenness into account. So evenness is how evenly distributed they are among the population. So on the sandy bottom, I won't go through all these numbers, but you can see that sandy bottom is generally less than the eelgrass beds. Again, that shows that the eelgrass beds are a little bit more diverse. The higher the number, the more diverse. But again, data is variable. And again, you see the pattern with the eelgrass going up first and then down, but the same not true for sandy bottom. Again, no statistically significant difference between the 2 locations and no statistically significant difference between the 3 trawl days. Okay, next I looked at Plow's evenness index. So unlike Shannon's, this is kind of more focused just on the evenness, and it takes kind of Shannon's and takes that a step further in terms of evenness. So the closer you are to the value of 1 would be a perfectly even community. You could see these numbers here. Again, the patterns are kind of in the graph a little bit different. You see just a steady decrease, but it's very similar for the eelgrass, and that decline for the sandy bottom again. So again, no statistically significant difference between the 2 locations and no statistically significant difference in evenness across the trawl days between habitat types. Finally, I looked at Jacquard's index. So this one's a little bit different. This is actually going to be comparing 2 trawl days or 2 samples using a common factor. So my common factor here is going to be habitat type. So I'm comparing trawl 1 versus trawl 2 in the sandy bottom, trawl 2 versus trawl 3 in the sandy bottom, and so on and so forth. Again, the higher you are to 1, the more similar they are. So the sandy bottom is actually more similar, which kind of, to me, shows that it's less diverse. There's less change, there's less dynamic reactions going on. And because Jacquard's index measures similarity, a statistical analysis was not done here. But it can be noted that trawl day 1 and trawl day 2 were the most similar for both locations. So my conclusions, first, it's just very important that biodiversity cannot be determined just using 1 measurement. It's important that we look at all these measurements in combination, and then we can draw our conclusions. Again, it's a little bit harder for me. I only had 3 trawls. I can't really draw any specific conclusions, but I'm hoping in the following few years, we'll be able to do some statistical analysis that will actually be impactful, laying out those detailed steps for repeating this data. Also, being in charge of an experiment involves a lot more moving parts than expected. If you're working under like an advisor or something, you kind of have that support system. When you're doing it on your own, you really got to be in charge of everything and know exactly what you're doing. So it takes dedication, passion, and hard work to make it work. Finally, I just want to say thank you to the Department of Fish and Wildlife and my mentor, Karen Byrne, as well as my fellow program directors, May Skirba and Mary McKenna. I want to thank all of SoMAS, both the staff and the students, my mentor, Dr. David Taylor, and the entire MCP program. So thank you guys very much. And questions? Yeah.
Betting the rules, so I have to ask a question. But this time I'm not asking a question, I'm making a comment. I really like this project, the way you build it, you built it from the ground up. The caution I'll give you, if you are using fractometer, that's the most erratic instrument you can use in my science, and it's not gonna give you the signal you are looking for, because you wanna look at it change over a long time. What's the impact?
Yeah,
and you're not gonna get it.
yeah.
You need to get the sensor that can measure salinity very well.
I think if we had a we actually had a YSI in the beginning of the season, and I went to test it out, and the first time I tested it out, they were like, "Yeah, it's broken." And they said we're gonna get a new one. They also told me we're gonna get a new pontoon boat. These things are, yeah, YSI would be better, and I think I could still make that transition. You know, if I continue on with this project next year. Any other questions?
I have a question.
Yeah.
So what's next for you?
Uh,
With the New Jersey.
yeah, so,
Time, so.
well, what's awesome is I just landed a high school teaching position, so I have my summers off. So I'll keep working at this spot, for as long as they'll have me around. So I'm really excited about it. And now that this is done, I can focus on lesson plan. So it's a quick turnaround.
Okay. Well, congratulations.
Thank you.
Great. Great. Okay, next. Magdalena Kelly Miller. The Tales of the Forgotten Risso Dolphins. The Necropsy Case Files. I like the title that you picked. And faculty mentor Oliver Shipley. Internship supervisor Ellie Siwak at MCs. Great. Let me get you hooked up. And over to you.
Good morning, everyone. My name is Magdalena Kelly Miller, and I did my internship at AMC's. I did my project on the Tales of the Forgotten Risso Dolphins, the Necropsy Case Files. My internship advisor was Ellie Siwak, and my mentor was Oliver Shipley. Today, I will be discussing the importance of AMC's, marine conservation through action, Risso dolphins anatomy and behavior, necropsy case files, the threats to Risso dolphins, and the broader impact. AMC's is a nonprofit organization that was founded in 2016 by 4 passionate volunteers. AMC's mission is to promote conservation efforts through action, and they do this by education and outreach events, sea turtle rehabilitation, and mortality investigations. In New York, we have 4 species of sea turtles, 5 species of seals, and over 15 species of whales and dolphins. If possible, I encourage everyone to put the stranding hotline into the phone just in case you ever see a stranded sea turtle, whale, dolphin, and you have it just in case for reporting. So one major education and outreach event that I was a part of at AMC's was beach cleanups, which happens all over Long Island, such as Halleck State Park Preserve, Lido Beach, and Jones Beach. Beach cleanups are essential to protect marine mammals and sea turtles from being sick, injured, or killed. When completing beach cleanups, every group fills out a data sheet telling what marine debris they found, which assists AMC's in promoting mitigation strategies. During my internship, I was also involved in sea turtle rehabilitation. During the winter months, AMC's received 20 cold-stunned Kemp Ridley sea turtles from Massachusetts. When I started my internship, there were 3 sea turtles left. The rest were flown down to North Carolina by a nonprofit organization, Turtles Fly 2. I was involved in sea turtle husbandry, which included medical attention, water quality, and feeding. This summer, AMC's had 2 sea turtle releases. AMC's partnered with the New York Aquarium and the DEC at Coney Island to release a Kemp's Ridley sea turtle, which is the most endangered sea turtle in the world. This was a really special opportunity to witness because it showed the work of many environmental organizations coming together in support of conservation efforts. This summer, I also participated in mortality investigations at AMC's, which involves necropsies. This summer, there was multiple strandings of deceased loggerhead sea turtles, and some were due to vessel strikes. When responding to a stranded animal, the first part of the necropsy is conducting a level A findings, which involves measurements of the animal, taking photographs, and notes on the body condition. Then the animal's organs are dissected one by one and samples are taken so we can investigate how and why the animal died. On July 2nd, 2025, a team of us responded to a loggerhead sea turtle near White Plains, New York, and we conducted the investigation in the field. During the necropsy, a pivotal moment happened for me in which an older gentleman was spotted by. I went up to talk to him about the importance of AMCs. He lived in the community for about 20 years and wanted to know more about what we were doing and the process of our mortality investigations. He said that he was shocked when I mentioned that loggerhead sea turtles are native to the area, just because he's been there for so long and he didn't even know that they were there. So my motivation for the project was over the summer, I wanted to involve all these components that I completed at AMCs, specifically focusing on their mission of conservation through action. So I wanted to involve the necropsy case files, education and outreach, and the issue of marine debris on Long Island. As a result, I decided to research Risso dolphins and the 8 AMC's necropsy files on the Risso dolphins from 2019 till 2025. My objectives included investigating the 8 AMC's necropsy case files on Risso dolphins, identifying if there is any correlation in where Risso dolphins are stranding on Long Island, and to create an educational presentation that AMCs will use in future outreach events. So Risso dolphins is the only species of the genus Grampus. The Risso dolphins is the 5th largest member of the family Delphinidae. It was first identified in 1812 by Antonio Risso, and it is in the subfamily of blackfish that includes the false killer whales, pygmy killer whales, and short-finned pilot whales. So Risso dolphins are not that well known in the public eye, but they're very famous in New Zealand. So from 1888 to 1912, there was a famous Risso dolphin named Jack that swam along ships, guiding sailors through the French Pass in New Zealand. So the French Pass is a very narrow, rough pass, and it is to be believed that when Jack wasn't there, the crewmen would crash and die at sea. So they would always wait for Jack to lead them through the pass. Jack was the first individual marine mammal to be granted legal protection, and the Risso dolphin got so famous that even Mark Twain went to New Zealand to visit Jack. So Risso dolphins have a robust anterior bodies and a rounded head. Risso dolphins have one of the tallest dorsal fins in proportion to the body length of any citation, and this is the #1 reason why they get confused as other marine mammals. Risso dolphins' calves are gray to brown in coloration, and then as they mature, this coloration lightens, which happens by intraspecific interactions, which is when Risso dolphins play and fight with one another, creating marks on their bodies. This is also a #1 way that they are identified. Age of sexual maturity is 8 to 10 for females and 10 to 12 for males, reaching up to 8.5 to 13 feet in length and weighing up to 600 to 1,000 pounds. Risso dolphins live in temperate and tropical ocean waters, including the West Coast, Southeast Pacific Island, and Mid-Atlantic areas. These marine mammals are deep divers and prefer the continental shelf edge and slope. They can hold their breath for up to 30 minutes and dive up to 1,000 feet. Risso's dolphins' primary food source is squid, which undertake diavertical migration, which is when organisms move up and down in the water column at night. The Risso dolphins take advantage of this and feed at night, in which the squid are higher in the water column, making it easier for the marine mammal to hunt. Risso dolphins are very active marine mammals. They can be seen swimming with other cetacean groups. They are observed bothering gray whales and harassing short-finned pilot whales. There are also observed spy hopping and surfing in swells. From 2019 to 2025, AMCs has responded to 8 stranded Risso dolphins. This table shows the accession numbers of each of the Risso dolphins given to by AMCs. The table shows the date of when the Risso dolphin was stranded. The code is given by AMCs showing the condition of the carcass during the response. This table shows that out of the 8 necropsy case files, 5 had a body condition of thin and 3 had a body condition of emaciated. So body condition shows the health of the marine mammals. When the body condition is poor, it is more challenging for the marine mammals to thermoregulate, forage for food, and reproduce. Out of the 8 necropsies completed by AMCs, only 1 was a yearling and the other 7 were adults. Out of the 8 necropsy case files, 5 were male and 3 were female. This table shows the location of the stranded Risso dolphins. And from this data, I was able to plot these points into GIS, creating a map of Long Island to display the location of the stranded Risso dolphins. Today, I would like to talk to you about 3 of the case files out of the 8 that I investigated at AMCs. So AMCS 124 GG 2019 was initially stranded on April 1st, 2019. It was stranded alive, and it was and the New York Marine Rescue Center and DEC responded and refloated the animal. But sadly, it restranded following release and reported deceased on May 14th, 2019. AMCS 107 GG 2024 was stranded on July 23rd, 2024. The body condition was emaciated. The tongue had ulcerations. There was gastric ulcerations, and the intestinal tract lining had severe ulcerations. So the stomach was full of seaweed and contained marine debris that included 4 plastic gloves and 1 Almond Joy candy wrapper. Risso's dolphins' primary food source is squid, which is challenging to hunt, and they need a lot of energy to feed. As a result of the stomach being full of seaweed and marine debris, it is assumed the animal was sick and in poor health, not having enough energy to hunt squid. So it ate things that were accessible but had no nutritional value, ending in the animal starving. Another stranded Risso dolphin happened in 2025. The animal had possible pox. The body condition was sunken in. The blubber had discoloration. There was no stomach content, and the animal was severely undernourished. And the possible cause was starvation. So threats to Risso dolphins include longline fishing and bycatch, gillnet and porcine fishing, marine debris, prey depletion, and hunting in Japan and Sri Lanka. So the broader impact, further research must be conducted involving Risso dolphins' diving behavior, marine debris, and emergent contaminants of concern. Conservation efforts need an interdisciplinary approach for impactful solutions with community involvement, which is shown by the work done at AMCs. I would like to thank the AMC's team and my mentor, Dr. Oliver Shipley, for all his support during this process. Thank you, and is there any questions?
Is it assumed that the plastic gloves were consumed after the organism was already starving, essentially, or that might have filled their, like, kind of like we talk about sea turtle eating the plastic bags and that causing them to essentially not have room to consume their primary food?
Yes, that's correct. So it was not in the best health to begin with, and to eat squid, it takes a lot of energy. So they were just looking for food, and as a result, they digested seaweed and marine debris.
Do these animals routinely move into the Great South Bay, or is that just something that happens, when they're not feeling very well? Because we've had also mako sharks and stuff wash up in the Great South Bay, and that's obviously not a typical habitat for a pelagic animal. So I was just curious.
Yeah, I'm not exactly sure, but if you look at the wider database of marine mammals stranding On Long Island, they seem to be like appear like there's like every 2 years to be like a stranding of a Risso dolphin. So, but most are sick. Thank you.
Yeah, again, I'd like to acknowledge all the organizations that work with us over the years. AMCs, thank you so much. You've been very generous with your time. Seems like every year we have at least one, if not more, students working with you. And thanks for showing up in person too. Okay, next we have Christine Kieras. Ontogenetic assessment of resource use in striped bass using stable isotopes. Faculty member is Oliver Shipley. Okay, very good.
Hi, my name is Christine Karras, and today I'm going to be talking about an ontogenetic assessment of resource use in striped bass using stable isotopes. So some background on striped bass. They are an anadromous fish species, which means that they need to return to fresh water in order to spawn, but they spend most of their lives out in saltwater. So they spawn in brackish or freshwater during the spring and stay there for at least the first 2 to 3 years of their lives, at which point they are either going to stay in that same estuarian or freshwater system or move out into the ocean. My project is on specifically the ones that move out into the ocean. And they are, they're opportunistic predators that consume a wide variety of different prey types. However, we're not entirely sure like specifics. We just know broadly what they're consuming. So that leads to some questions, and it's important to study them right now because they are currently experiencing their lowest recruitment numbers on record. So stable isotopes. So they are used to study diet and trophic/habitat niche of organisms due to this stair-stepping behavior, where they both carbon and nitrogen get enriched from metabolic processes. Delta 13C values are used to discern habitat use variation as well as movement capabilities, and the amount of 13C in a sample is affected by what primary producer it gets its food from, which is important to keep in mind as the striped bass are moving into the ocean. The delta, and we can figure out the amount, like which plant it is getting its primary producer is by the amount of, because the carbon isotope fractionation changes depending on what the primary producer is. Delta 15N values reflect trophic variation in an organism in a food web. Nitrogen at the coast is affected by runoff, so coastal organisms have a higher nitrogen baseline than the open ocean ones do. The values also get higher with age since 15N is building up in the body from the prey they're eating, as you can see from this graph. And the variability of both delta 13C and delta 15N can be measured over time via metabolically inert tissue, such as scales. So the goal of the study is to quantify ontogenetic changes in resource use of ocean striped bass captured off of the South Shore of Long Island, which is this area right over here. We use scales for this process because they are metabolically inert, so you can get a long time record from them, and they can also be collected non-lethally. So the first hypothesis is that if striped bass are migrating into the ocean between years 2 and 3, there's going to be a significant difference in delta carbon 13 and delta nitrogen 15 between those 2 years. And the second hypothesis is that if the food resources being used by different age classes, once they are in the ocean differ, the delta 15N will be different. So scale preparation, I don't know why the lines didn't show up. So we collected scale samples from striped bass that were collected off of the South Shore of Long Island, and that were also acoustically tagged for another project. And the acoustic telemetry data from that project was used to assign natal habitat to the fish. The samples were then acid washed with a weak hydrochloric acid, rinsed with DI water, and then dried. The dried scales were aged with a dissecting microscope along the bands in a similar way that you do with a tree. And then the lateral field, which is this part of the scale, was also removed to help with dissecting. So overall, 213 growth bands were dissected from 30 different individuals and weighed up to between 0.3 and 0.35 micrograms. They were then also, these standards were weighed and ran on the same machine as the samples in order to check for analytical precision and to measure machine drift. So the samples were run on this machine, which is a thermoscientific delta V isotope ratio mass spectrometer coupled to a flash elemental analyzer, or EAIRMS, and statistical analysis was done in R. So the age-specific delta 13C and delta 15N values were compared to identify differences as individuals age. A Levine's test was run to test for homogeneity of variance, and if that was significant, a Kruskal-Wallis test was run, and if the Levine's test was not significant, then an ANOVA was run. A post hoc test was run to figure out differences between growth bands if either the Kruskal-Wallis or the ANOVA came back as significant. A Tukey's test was run with the ANOVA, a Dunn's test was run with the Kruskal-Wallis. So results. So this is just general scale information. The upper graph shows the different natal habitats that all of the fish came from, with the majority of them coming from the lower Hudson River. The bottom graph shows the distribution of ages of the growth bands that I got, with the majority of them having 5 or fewer growth bands and some having more, with 2 individuals having 9 growth bands, up to 9 growth bands. So these results show delta 13C changes. The top one shows it like throughout the lifespan of an individual. The bottom shows it via like average for each growth band. So in the top graph, you can see there's a lot of variation between the individuals, which is due to the differences in all the food that they're eating. The bottom graph, you can see delta 13C becomes less negative as age increases up to around year 4 or 5, at which point it goes back down, which suggests that the source of primary production is changing from being more freshwater to being more benthic to being pelagic. And you can also see that there is statistically significant differences within the growth bands. I'll go into that more later. So both of these graphs show changes in nitrogen, similar to the last slide. Top one shows it as like throughout the lifespan of an individual. Bottom one shows it averaged for growth bands. There is also a lot of variation within the nitrogen, even more so than in carbon, which is also due to different food types that they're eating. In the bottom graph, you can see delta 15N decreases until also around years 4 or 5, at which point it starts to increase again. The decrease at the beginning is due to the result of the shift from being in the Hudson River to going into the ocean, with the decreasing in the amount of background nitrogen, and the increase is from the ontogenetic diet shift, and there was no statistically significant difference between any of the growth bands. So overall, there is a statistically significant difference between growth bands 1 and bands 3, 4, 5, and 6, and then also between growth band 2 and growth band 5 for the delta carbon 13 values. And there was no statistically significant difference in the delta 15N value between any of the growth bands. There's a clear ontogenetic shift in delta 13C values compared to delta 15N, although you can see a shift. So the change in delta 13C suggests that the source of primary production is changing from being freshwater to being benthic to being pelagic. The trend in delta 15N suggests that the decrease in the beginning could be the result of a habitat shift from the Hudson into the ocean, because it's going from an area that has relatively high nitrogen values to going to an area that has lower nitrogen values. And then the increase is due to the ontogenetic diet shift, because they're eating larger organisms which have more nitrogen 15 in them. For both, there's variation among individuals because of different environmental conditions, such as between all the different natal habitats that they're in, and also within all the different food that they're eating. So all of this is important because this information could be used to create better management plans for the species by making them more targeted to the types of food that the striped bass are eating, such as if they're eating more food from the benthic, so you can make the management plans more targeted to benthic organisms, or if they're eating more pelagic, you can target to more pelagic species. The plans also need to focus on every life stage of the fish because they're vulnerable to overexploitation at all those stages. So if you're only protecting them once they're in the ocean, then they can still be overfished in their natal habitats and the population number is still going to go down. And this is important because the recruitment numbers are still currently at their lowest on record, with juvenile striped bass having far below average numbers for the 5th consecutive year in Maryland as well as in Virginia as of 2023. I could not find any more up-to-date information. And so if we can properly manage the species, there's more opportunity for them to be able to bounce back. So working in an analytical lab, I was also able to pick up some other skills. So I was able to use the striped bass, I was able to use the stable isotope methods that I used on striped bass on a different type of tissue with muscle tissue, specifically from sharks. I learned how to do lipid extraction on these samples since they have a higher lipid content and we were measuring collagen. And so in order to not have overly inflated nitrogen values, we had to remove all of the lipids. I also learned how to set otoliths and epoxy so that they could be sectioned using that machine. And a line was drawn in the otoliths in the middle so that when you cut them, you would be able to see all of the different bands. And then I was also able to go out fluke fishing. And so I was able to catch and then tag a fish so that we could collect data for a different project. Here are my references, my acknowledgement section. Thank you. Any questions? Yeah.
How did you obtain like the striped bass samples? And then if you talk about how you actually take the scale sample off of that?
So I was not actually a part of collecting any of the samples, but from what I understand, it was via rod and reel angling. And then I think you just scrape the scales off of the fish in order to collect them.
We have a bunch of surveys. You can target the rod and reel, but also direct control surveys as well in the fall to catch them.
Doesn't kill them either.
It does not, no.
It just feels like an oyster shucker. It's like a
Come on, more questions.
How difficult was it to dissect 9 growth bands and get enough material for analysis?
Very difficult. After about growth band 5, they started to get really close together. So you had to be like very precise with cutting them up using the scissors. Yeah.
After you sectioned otoliths, what was done with those otoliths?
They were put onto microscope slides for later analysis. I did not get to that part of it.
We're gonna fire a laser at them. We're gonna fire a laser at them for carbon and oxygen isotope measurements. I've actually seen it.
We profile the problem, the raw analysis. Also, where we had.
Yeah.
Yes.
So you talked about how the primary producer changes. And I was just wondering if you had an understanding of like what kind of representative species. Is it always planktonic at the base, or could it be, a freshwater grass or algae, seaweed kind of thing?
Yes, I believe it does change. I know at least for in the ocean, it's more phytoplankton, and then when they're in their estuarine systems, I would assume it's more grasses and algae and seaweeds.
Okay, what's next for you?
I'm going to be working at least for a month up at the Great Lakes Center up at Buffalo State University.
Cool.
Yeah.
On striped bass?
No, I'm doing monitoring surveys of like the benthic invertebrates within the different Great Lakes.
They do have striped bass.
They do, yes.
Okay, that sounds clip you. Okay. Yeah. Yeah. Okay. Let me get you, I'm a figure it out. Too much knowledge. Thank you, I check out it. Okay, so while we're waiting for this to come up, our next speaker is Jennifer Lander, and her title is Spatial and Biological Insights from a Long-Term Mark-Recapture Study of Horseshoe Crabs in New York, Implications for Conservation and Management.
Mouthful.
Yeah, it's a mouthful. Okay. Bob Serrato served as her faculty mentor. Chris Scott from the New York State Department of Environmental Conservation was the internship supervisor. Okay, all right, go Jennifer.
All right, good morning, everyone. So my name is Jen Lander. I interned at the DEC, and I'm going to be talking about my Mark-Recapture study on horseshoe crabs in New York and implications for conservation management.
I have a mouse, sometimes I had
Okay.
to forget to put back
That's
the
good.
presentation.
There we go. Fun. All right, so why are horseshoe crabs important? For a variety of reasons. Their eggs provide a food source for migratory shorebirds. They're used for bait in the whelk and eel fisheries, and their blood is used for LAL testing for endotoxins and fungal pathogens. And because of these uses, specifically the economical and biomedical, there were coastwide declines in 1998 of the population, causing concern not only for their population, but also for migratory shorebirds such as the endangered red knot. So the Atlantic States Marine Fisheries Commission created the Horseshoe Crab Fisheries Management Plan during this time to assess regional differences along the coast and to help sustain horseshoe crab population. And one of the recommendations of the FMP was to incorporate spawning surveys coastwide. So the New York Horseshoe Crab Monitoring Network is a citizen science network that was established in 2007 in collaboration with DEC, Cornell Cooperative Extension, and Stony Brook University. It has grown to 30 sites with over 800 volunteers annually. It has a standardized protocol that was based off the Delaware Bay survey, and it has 12 sample nights a year through May and June, which coincides with the peak spawning times of horseshoe crabs. Volunteers walked a set transect at sites to gather spawning activity data. Volunteers were also given U.S. Fish and Wildlife button tags so they could tag crabs. They measured the prosomal width of each crab, sexed the crab, and also reported on shell condition and any biofouling for each crab. So following the implementation of the FMP, ASMFC established state-by-state quotas in 2000. New York was allocated just over 366,000 crabs for the bait fishery. It's important to note that New York is a bait-only fishery. There are no biomedical permits issued in New York. In 2004, DC voluntarily reduced that quota to less than half of the FMP's allowable take. So that is 150,000 crabs per year. In 2020, following the 2019 benchmark assessment, which categorized New York region as poor status, DC implemented 2 5-day lunar closures in late May and early June, making it illegal to harvest crabs during that time and letting these crabs deposit their eggs on the beach undisturbed. In 2022, DC created regulations use of bait bags, increasing the viability of the bait in the whelk pots and lessening the demand for horseshoe crab harvest. And most recently in 2025, DC implemented 2 additional 5-day lunar closures to coincide with all the new and full moons in May and June, again during those peak spawning times for horseshoe crabs and essentially creating a type of seasonal closure. Other regulations include permitting requirements and also mandatory reporting by fishers. Areas closed to harvest year-round include West Meadow Beach, Cedar Beach and Mount Sinai, Fire Island National Seashore, and Gateway National Recreation Area, making largely Jamaica Bay illegal to harvest. So the goal of this study is to update and expand Mark-Recapture survival and movement estimates using newly compiled data sets spanning from 2007 to 2024, and then to compare this study to the earliest study by Bob et al., 2019, which used a data set from 2007 to 2016, and pretty much just to expand beyond that 2016 date with this new data, and then use these findings to assess regulatory changes on survival and movement, and to identify spatial differences at the sub-regional level. So after filtering and cleaning the data for analysis, following the 2019 study protocol, I created a multi-state Mark-Recapture model in program Mark using 3 geographic states or region: Jamaica Bay, which includes New York Harbor, Raritan Bay, and northern New Jersey; South Shore, which is the entirety of South Shore of Long Island, its bays, Atlantic Ocean; and the North Shore, which is Long Island Sound, Peconic Bays, and recaptures in Connecticut, Rhode Island, and Massachusetts. I set survival estimates, recapture probability, and transition probability, and I created 2 models, which I weighted average to create my final survival estimate. So after all the clean data, found that 57,535 tags were released for the entirety of the study, and for a Mark-Recapture study, a recapture means a previously marked or tagged animal that has now been observed again or caught again. So of those release tags, 7,368 were valid recaptures, meaning it could be an individual that was recaptured multiple times throughout the study. And then of those, 2,966 were unique recaptures, meaning it was the most recent observation of a tag following its initial release year. And for the entirety of the study, it was found that the recapture rate was 5.16%, which has increased in recent years. The earlier period was about 4.07%, and post-2016, it rose to 5.84%. And it's in line with the increase in tagging effort in these recent years. So for crabs at release, the operational sex ratio was found to be 2.2 to 1 male to female ratio. So there's definitely a male bias, which is pretty on point to a lot of the spawning survey studies. The frequency of male release and male recapture is higher than female. For the unique recaptures, 63.5 were found alive, 27.5 were found dead, and 9% were of unknown condition. New York dominated the majority of the recaptures to the study, with New Jersey and Connecticut giving the most next largest contributors. This density map is those unique recaptures on the bay and estuary level. And you can see we got our 3 main, Okay, 3 main sites right there. So we got Jamaica Bay, Smithtown Bay, and Moriches Bay as those big recapture sites, and it does go in along with the high tagging effort sites of the spawning survey. So also distribution by water body, the majority of the recaptures were in Long Island Sound, followed by Moriches Bay, Jamaica Bay, and Atlantic Ocean. So going back to program Mark estimate, the survival probability was split by region and time period. The red is the pre-2016, blue is post-2016, and you can see that there has been some increase in Jamaica Bay and South Shore in these recent years. It's definitely interesting in South Shore, since South Shore comprises over half of the commercial harvest of horseshoe crabs annually. And then North Shore is pretty the same, maybe some slight increase. So overall, just showing some stability and improvement in these recent years. This is showing movement and flow of these crabs between regions. So the color is going mostly across into that same region. And then there is some flow between, let's say, Jamaica Bay and South Shore. That's only accounting for 2% of the overall movement. North Shore and South Shore is 1%, even less than 1%. And then you got a little bit of flow, Jamaica Bay and North Shore, which is even less than 1% is the least amount. So overall, Jamaica Bay and South Shore had 89% site fidelity, North Shore 97%, meaning that these crabs are remaining in their region of release. So overall, survival rates varied regionally. North Shore had the highest survival probability, with South Shore and Jamaica Bay having least, but they have shown improvement in the recent years. Movement analysis revealed high site fidelity for most individuals. However, there's minimal exchange between these regions, showing that there's definitely population dynamics within each region. And that is consistent with the 2019 study as well. So this data is indicating that continued population stability and improvement are being seen under the current management. It warrants ongoing monitoring, but no immediate major regulatory shifts. So definitely want to continue monitoring closely and cautiously, but it is an optimistic outlook. We want to consider a 10-year generational lag. So horseshoe crabs mature after about 10 years. So regulations such as Luna closures that were implemented in 2020 probably won't see a population shift until about 2030. And there is precedent for this. In Massachusetts, they didn't start seeing an increase in their horseshoe crab population until a decade after the implementation of their lunar closures. Habitat restoration is also important. So taking into account Jamaica Bay. Jamaica Bay obviously had the least amount of survival, even though it has some improvement. However, Jamaica Bay is largely illegal to harvest, so it's important to look at other non-fishery related factors that might be impacting that survival, such as hardened shorelines, water quality, and also for continued support for citizen science and data continuity. Some recommendations is to combine survival estimates with spawning activity indices. So these indices are showing stable and increasing trends at the 5 and 10-year trend mark. Spatial differences require adaptive change to look at each region specifically, to continue monitoring, tagging, and public engagement. And lastly, to perform more candidate models for an average weighted estimate that is better to compare to the 2019 study. Please enjoy this video. It was from the Pikes tagging blitz this year, where about 1,000 crabs were tagged in that one night. But I would really love to thank Dr. Bob Serrato and Dr. Matt Scafani for their expertise and their endless guidance throughout this whole process. Special thanks to Dr. Justin Bob, who without his knowledge and information on modeling, I definitely wouldn't have gotten as far as I did in this project. Thank you to Chris Scott, who's the unit lead for the MISC unit at DEC, for his collaboration and endless support. And that appreciation is extended to the entirety of the MISC unit and DEC staff. Also, thanks to U.S. Fish and Wildlife Service for providing this data for the project. And lastly, to SoMAS and MCP program staff for the opportunity.
Great. Questions?
Yes.
What is how do you have an unknown condition of your horseshoe
Yeah.
crab?
That is mainly the tags are found. So you find tags on the beach, but there's no crab. So you're not sure if they're alive, dead, or yeah,
That makes
unknown.
Where was that video taken?
This video is Pikes Beach, Merches Bay. So actually the one.
And it's at night.
Yes, so this is actually captured by one of our lieutenant ECOs, and he used a special night vision, and they came out so good.
Yeah, you should see it at night. It's
Yeah.
amazing. Other questions from the audience?
Great job, Jen. There's been a lot of talk of imperiled status of your horseshoe crabs. How would the data look differently if that was true, I guess?
So, well, there is a lot of concern about their population. If there was seeing a decline, the data would be showing that post 2016, there would start being a decline and not a stable or even slightly improving population. So at this point, it's showing that the current management and regulations are working, and it doesn't really require further bans or reduction in harvest warranted at this time.
Question.
Yes.
So at the beginning, you talked about why horseshoe crabs are important to other organisms like red nuts, to us, for how we use them as bait or for testing. But a lot of people fall in love with horseshoe crabs because they're just really cool organisms. could you tell us a little bit about what makes these creatures so interesting and unusual?
Yes, so it's actually, they are near and dear to my heart. I fell in love with them early on in my career back in high school when I would go out and survey. So they are really interesting. They are older than dinosaurs, so they are pretty ancient creatures. And they've been around, and they haven't had any evolution. They've just continued surviving through mass extinctions, while others did not. And yeah, so obviously they're important for a variety of reasons, and also their blood, which is blue blood, is just important all around.
How about their eyes?
Oh, well, they have compound eyes, but they also have multiple eyes throughout their whole body, which are like light sensors. Even on the tip of their tail, they have these special eyes. So they're very cool. They're very interesting creatures.
Okay. Any other questions? Okay. All right, thanks a lot. Oh, yeah. Thank you. Okay, our next speaker is Melanie Lazan. And I have a slightly different title than you on this, but it's close. Okay. Yeah, it looks like you did, but it's bacterial contamination in Mecox Bay, identifying sources of Enterococcus and developing mitigation strategies and public health notifications. Over to you.
Right. Hello, everyone. I'm Melanie Lazan Warren. I did my capstone project on the bacterial contamination of Mecox Bay, particularly the Enterococcus bacteria. And we focused on developing mitigation strategies and some public health notification systems. How do I advance? There we go. Just a quick overview. I'll do a quick background and introduction. Go over some main goals and the MCP connection of the project. I'll go over the methods, results, and brief discussion and conclusion. So this is an ongoing project with the Mecox Bay Conservancy and the Gobler Lab through Stony Brook. Dr. Chris Gobler was my advisor on this project. Mecox Bay is a shallow, brackish coastal body of water located in Watermill on the east end of Long Island. It's approximately 1,100 acres and bordered by about 300 waterfront properties, businesses, and farms. It's a critical habitat to various species, including 2 endangered shorebirds, the piping plover and least tern. And it faces a multitude of environmental issues such as sea level rise, flooding, water quality issues like elevated temperatures, low salinity, and low dissolved oxygen. It also has issues with algal blooms and pollution. And there's a rising concern over the Enterococcus bacteria, which it got some news or bad press on a couple years ago. So that's what led to this project. So Enterococcus are key indicators of fecal contamination, and they pose a significant risk to both humans and the health and quality of the marine ecosystem. It can reduce the utility of the ecosystem and like the recreational activities in the area, like fishing and swimming, and it can cause several human health issues like gastrointestinal, skin, eye, ear, and respiratory illnesses. A little background on Enterococcus: it's a ubiquitous gram-positive group of bacteria. It's primarily present in gastrointestinal tracks of many animals, including humans. It's used as a fecal indicator bacteria for assessing water, recreational water quality globally. And the EPA recommends using Enterococcus as a fecal indicator bacteria in brackish and marine waters, such as the Mecox Bay and other areas on Long Island. And they can be present in sand and sediment, and they persist in the waters as well. And wave action and tides can recirculate the bacteria from the sediment and the beach sand. And that's just like one of the cultures I did. So the fluorescent is showing the presence and the concentration of the Enterococcus. So the main goals of this project is to conduct a detailed assessment of Enterococcus in the bay, and also analyze the sources and identify geographic hotspots, and the animals, identify the animals that the bacteria is originating from. And we also wanted to develop some strategies, some practical strategies of mitigation and remediation, and also just enhance the public awareness and community outreach. And the connection to MCP is that it directly supports marine conservation through helping to protect the ecological health and recreation of these coastal waters and from microbial pollution. And it also aligns with policy by giving a scientific basis on coastal management decisions and strategies. So quickly, the methods, we did some field sampling at 9 different sites around Mecox Bay, which is all highlighted by the markers. We took YSI measurements to determine to observe like environmental parameters. We did bacterial cultures of Enterococci, fecal coliform, and Vibrio. Vibrio is not a fecal bacteria, but it's also present in the bay, and we wanted to get a level on that as well. We did filtering in the lab for DNA analysis. We ran a fluoroprobe on the samples to see the phytoplankton levels. That Mecox also has, Mecox and Mill Pond as a tributary to Mecox Bay. We has some blue-green algae levels, so we wanted to determine those levels there. And we did some DNA analysis, which included PCR and microbial source tracking, which is how we determine which animals the bacteria is originating from. Sorry. And these are just some pictures of my methods. So this is the culture and DNA extractions tools and the filtering. And this is just me on the field doing the field sampling. And I actually brought my son along last week, so he helped with the processing, whether he liked it or not. But he did like it, and it's his birthday today, so I have to make a little proud mama mention. So results, this is the temporal trend of the Enterococci level or concentrations in the bay throughout the May to August sample period. So each line is every site, and then the dotted line is the precipitation, overall precipitation over the summer. So you can see that the spikes of Enterococci followed the precipitation. And this is the spatial distribution of the average Enterococci levels at each site. So you can see that the Hayground Cove Bay Avenue site, which is the most developed site on Mecox Bay, has the highest average concentrations, with Mill Creek being the second highest. And this is the spatial distribution of the fecal coliform levels. This one showed a little bit of a different trend. The highest level or average concentration was at the Flying Point site, and we're not quite sure. This could have some just different processes there. It's not very developed. So it could be that there's some other issue that we need to identify there. Oops. And this is the results from the microbial source tracking, which I found very interesting. These are the relative average. This is the relative average abundance of the 4 genetic markers that we tested for, which were small dog, ruminant, which are deer, bird, and human. So you can see that the small animal or small mammal and dog marker dominated the relative abundance overall and at each site, which is indicated on the bar graph. And there was very little human, zero or very, very, very minimal markers of humans. So that shows us that it's not human related or septic related, and that this really guides where we needed to focus our remediation and solutions. So leading into the discussion, as I said, the mitigation efforts should focus on sites with the highest bacterial loads, which were the Hayground, Cove, and Bay Lane areas, and also focus on the particularly the pet waste management. And it shows that the elevated levels are likely due to stormwater runoff from these residential areas with these pet densities, and some recommended mitigation and solutions were that we would be road end buffers, rain gardens, and bioswales, and just increase public education on pet waste management. And to increase public health notifications and community outreach, we suggest continuing to do community workshops and meetings, such as these 2 events that my advisor, Dr. Gobler, led with his presentations. There was a founders meeting here, and then another conference at their local community house. And I also suggested just keeping websites and social media current, and an infographic, which I developed here just to make this dense information a little more digestible to the general public. These are just 2 examples of what a bioswale and rain garden look like. And then in conclusion, this study just provides a scientific basis for policies on pollution control. We identified bacterial hotspots with enterococci concentrations peaking at the Hayground Cove Bay Avenue site. The MST identified the dominant source of the contamination being dog and small mammal. Mitigation efforts should focus on these residential areas and target the source of contamination. We propose the green infrastructure solutions being road end buffers, rain gardens, bioswales, and just to increase public education on pet waste. And that's it. And those are my references. Any questions? Yes. Thank you.
Microbial source tracking is still has a requirement on just using very better oxy blueberries.
Yeah.
Possibly.
So I'm not sure on the costly, but the time it is involved, but what we do, we extracted all the the DNA from all the samples, which is a timely process. So throughout the summer, we just tried to like batch them so it wouldn't take up too much time. But it's a pretty quick turnaround if if you keep up with it.
But how long does it take to actually get the data? Vice versa.
One of my lab mates, we could get it, I guess within a day if you really wanted to go from sample to extraction, a couple hours, and then she ran it through the software. So it could take a day to a week, depending on time availability.
Beach closures and shellfish harvest in our basement.
Yeah.
They have an answer. And 24 hours stay. Beach water is contaminated.
Right.
As you show, a lot of sources of these fecal bacteria are waterfowl, small mammals, not necessarily indicative of human waste.
Mm-hmm.
But we have people serving them, so worse. And have those emergence of
Right.
shellfish
Right. Yeah. The actual like cultures take over like overnight, so that's something that is time dependent on. So, but they are very modest with closing things that I've noticed.
What do you mean by not?
Like I feel like they really want to have like a huge spike before they close down anything. Well, at least the Suffolk County Health Department, they haven't, because we had some elevated high levels, and they remained open. That was Enterococcus, not fecal, but yeah, it was interesting.
All right, it made this. What were your thoughts on the station? Different, had one site that was really high in enterococcus and another site that was really. I can move that.
Yeah, it was interesting. I'll bring the map back up because they were very different parts of the bay. So the flying point, this is where the fecal coliform was highest, and this is where enterococci was highest. So you can see this. This has been closer to the ocean. A lot of mixing. This had more development. Yeah, it wasn't really clear. I think it involves more research to determine why the fecal coliform is higher in that area.
Are enterococcus sensitive to smell?
I'm not 100% sure. It didn't seem like that was a factor. Yeah, because the salinities were maybe a little lower in that cove area. Oh, yes.
So you said something about proper pet waste management.
Oh, yeah.
What is proper pet waste?
I know.
management?
I was very surprised that it was so overwhelming. I would assume it's just coming from the roadways where people are walking their dogs. I guess encourage more clean up after them. It's very overwhelming too. So I don't know. I don't know what else is going on there for it to be so high from that source. But I would say just definitely clean up after your pets or your dogs, and I guess even at home, make sure you're putting it in proper disposal areas and not washing into the lawns and into the bay, I guess.
Okay, one last question.
Yes.
So has this information been made publicly available, and how was it received?
Okay, so publicly available, they do, the Mecox Bay Conservancy does post the levels and has like, I believe even weekly updates to their homeowners. I was reporting the results to the Suffolk County Health Department. And so whatever they do with that information, I am assuming they post it somewhere. And Surfrider also, I mean, they do their own testing and they post their results weekly or daily.
So I guess.
But I haven't, my advisor hasn't publicized any work yet.
I'd be really interested to hear how the locals respond to the source. I think that'd be really.
Yeah, I'm unfortunately, I couldn't make that community meeting, but my advisor did present that at that meeting. So I should have followed up with him to see what their response was. But
Okay, we need to
okay,
go on to the next. Okay. Okay. All right, our next speaker is Vicky. Did I get that right?
yeah,
Okay. Vicky S. How's that? And her advisor is David Taylor. And she worked with the Peconic Estuary Partnership. Her title is Assessing the No Discharge Zone in the Peconic Estuary. Okay, Vicky.
All right, hello. So my name is Victoria Skobajinski. I also go by Vicky. And again, I did my summer internship on assessing the no discharge zone in the Peconic Estuary because everyone loves to talk about sewage at 11 a.m. So the reason why we care about no discharge zones is because vessel discharge and sewage introduces a whole bunch of stuff like bacteria, viruses, nutrients like nitrogen and pollutions and toxins into our local waterways. And if it's too much or the wrong type, all these things can lead to shellfish bed contamination, harmful algal blooms, fish kills, and public health risks. And while, yes, it harms marine life, Peconic Bay is also home to a huge seafood and shellfish industry and relies a lot upon our fishing recreation, swimming recreation. So if someone's getting sick from eating fish that they caught or getting sick from swimming, their consumer confidence is going to go down, ultimately meaning that our local economy is heavily tied to water quality. So no discharge zones are fabulous areas where no sewage discharge is allowed. It was initially established under the Clean Water Act in 1972, and specifically in 2002, the entire Peconic Estuary was designated a no discharge zone, initially to protect shellfish beds and water quality. And specifically Peconic Bay's or Peconic Estuary's no discharge zone, you need a marine sanitation device if you're going to have a toilet on your vessel. A type 1 or type 2 marine sanitation device means that it has to go through an additional like treatment. And there's something called a Y valve. It just needs to be secured either with a zip tie, padlock. This is under the Clean Water Act, has to be secured. Type 3 MSD, basically, it's just a porta potty. It just goes into a holding tank. And then in all three cases, it has to be pumped out with a boat or a station. All discharges, including gray water, this is actually specifically under the New York State DEC, has to be discharged. So this includes things from dishwashers, sinks, showers, etc. All of it is prohibited in the no discharge zone. Civil penalties do occur up to $2,000 per violation and can result in the loss of your captain's license. So with this project, I wanted to assess the pump out boat and no discharge zone infrastructure, compliance, and the surrounding culture around pump out boats and stations. I was initially tasked by the Peconic Estuary Partnership to answer these questions because they had received some anecdotal evidence that there's an increasing number of larger vessels present in the Peconic Estuary and that they might not be fully aware of the regulations of the no discharge zone. So using this, I wanted to then research capacity gaps, funding needs, history and outreach opportunities, and then further recommend solutions for enforcement, education, infrastructure. And I was tasked with the question, what can the Peconic Estuary Partnership do? One of the key things that they do is partnership. So how can the Peconic Estuary Partnership help towns, marinas, et cetera, because their mission is to protect and restore the Peconic Estuary and its watershed. So I did this in a few different ways. So the first way was that I interviewed a whole bunch of people, boaters, harbor masters, municipal officials, environmental advocates from across the East End. I also interviewed someone from Block Island in Connecticut. I also was able to get my hands on this pump out vessel incentive program annual report form, such a handful. And it's basically just a form that at the end of each boating season, Suffolk County's Division of Environmental Quality requests that towns and villages that participate in this certain grant program that I will mention in later, complete this form that asks a series of questions. How many vessels did you service? How many gallons did you pump? And then 4 kind of open-ended questions like, did you encounter any difficulties? How do you finally dispose of the sewage? What are some future strategies that you have planned? And then what are some comments for the program? And this is actually optional for towns and villages to complete, and private marinas do not have to complete this form. So then I did an analysis of these volume trends and then vessel service data, my results. So I wound up interviewing 15 officials and 9 boaters. And one of the key conclusions that I received from actually everyone was that there actually is a very high awareness of this program. And at least among the local boater culture, many local fishermen and many local swimmers, they do agree that they don't want to swim and fish in sewage infested waters. So really compliance or non-compliance might come from out-of-state boaters or potentially some negligence. Several other challenges were just some inefficiencies in ordering parts, especially during peak season. Let's say that a part goes broken, takes a few days for it to come in, and then a boat is down for a few days. And then also there are some contracting issues with like when the boat needs to be offloaded, usually in some towns, a truck will come and offload it. There are some problems in that contracting, and some of the suspected discharges might have come from offshore. So under the Clean Water Act, you can legally discharge your sewage 3 miles offshore, as long as it's not in a no discharge zone. So for example, someone can leave the Shinnecock Canal, they can pump out, or for example, if you're going from the Peconic Estuary to Block Island, there is a gap where technically you can pump out. And then also there's some suspected violations that may occur during service gaps. So the pump out boats do not operate at night. There are, however, some pump out stations that operate 24/7. So violations might occur during this time. Another thing was that gray water requirements are very poorly understood. Some vessels have 2 separate holding tanks, one for sewage, one for gray water. Some owners don't understand that they have to pump out both in New York State. And overall, there were few violations. However, this isn't quite indicative of an 100% working program. It's a very hard problem to catch. Oftentimes, it might be another boater who they smell something and they are actually obligated or they're legally required to report that to the US Coast Guard. Or let's say that a pump out boat staff, they see that a boat is moored in the middle of a harbor. They've had 20 people on the boat, haven't used the service, then Marine Patrol can go board the vessel, or even just during routine, checks, Marine Patrol can board the vessel. Let's say like, oh, we're looking for life jackets, flares. Oh, your Y valve isn't closed. Okay, violation. So from the report form, you looked at the years 2020 to 2024. There was definitely an increase in vessels that were serviced in East Hampton. And then there was an increase in the reported gallons of effluent pumped in the village of Sag Harbor. They did add a boat in 2023. The biggest thing, though, is that there was very inconsistent data reporting. So some towns don't actually track the vessels that they service at all. Some towns didn't even submit a form certain years. And many stations lack flow meters, which just attach to the tank and accurately tracks how many gallons you pump. Another big thing, and especially the town of Southold and town Riverhead mentioned this, is that there's certain staffing shortages. So with the rising cost of living on Long Island, the very specific civil service rules, having to need a captain's license, and it being a seasonal position, it was really hard for certain towns to retain qualified and like consistent staff. Again, there's some mention of infrastructure mismatches. However, in that last comment section, towns like Town of East Hampton and Village of Sag Harbor did say that when they included more vessels into their whole infrastructure, it really helped. And that especially like Town of East Hampton, they said that they were actually very proud of how well their program is operating. So from all of this, I created a few recommendations. So the one aspect that I want to tackle was education. So I created this flyer for boaters that actually replicated what Village of Sag Harbor do. They have a flyer that they give out to every boat that's docked or moored that clearly states the no discharge zone rules, where to call for a boat, and then additionally this gray water requirement, again, because it's poorly understood. And then additionally to ensure that if you do have a type 1, type 2 MSD, to include a zip tie when you give out the flyer to actually ensure that every single Y valve is being closed. I believe that this is also a great way for Peconic Estuary Partnership to increase their partnership with private marinas and towns for further outreach. And like every single environmental issue, funding is always an issue. So specifically for staffing, but can also be used for vessels and infrastructure. I researched some key ways and grants and programs that towns, marinas can participate in. The Suffolk County Water Quality and Restoration Program is actually the one where that form comes from, and almost all town and village participate in. I just want to include it anyways. And then several ways that PEP can actually use their funding to help. Which they can cover the cost of captain's licenses, increase salary, and fund flow meters. So I created a flyer for town, state, marine officials where everything is just in one concise area. You don't have to look at every which way to determine which grant or program is best for your municipality. And one way also that I want to, is to amend Article 7 of the Suffolk County Sanitary Code, Water Pollution Control, Section 76709, Monitoring and Reporting, to actually require this annual pump out report form, mandate flow meters for this accurate tracking, and to actually include private marinas in reporting rules, because like Town of Shelter Island, they only use private marinas for their pump out infrastructure. And so there's no kind of like accountability coming from this. And also consider a no discharge zone boundary expansion to kind of clean up those gaps, for example, between Peconic Estuary and Block Island. However, this does require the coordination of the federal, New York, Connecticut governments. So one challenge that I experienced was actually getting in contact with marinas. Oftentimes I would try calling, emailing, and I would not get a response, or I would get we can contact you after the boating season. So I'd love to conduct in-person meetings with marinas to actually gather marina logs of the vessel size and where they docked, to actually verify this initial anecdotal report. And then because data drives policy and funding, to actually use this data to help further guide pump out upgrades. So the no discharge zone has actually prevented thousands and thousands of gallons of waste from entering Peconic Bay. And really, obviously, the success relies on infrastructure, enforcement, education, and these kind of coordinated improvements from environmental nonprofits, towns, marinas, ultimately means a cleaner water, healthier ecosystems, and a stronger economy for Long Island. These are my references, and I want to say a huge thank you to Joyce Novak, Jade Blano, and all the staff from Peconic Estuary Partnership, Dr. David Taylor, and the fabulous School of Marine Atmospheric Science, and Smokey Bear. I met him in Albany.
Okay. We do have time for a question. Quick question? That's a good question. All right, just loud enough.
Sure, so are there any technological advancements in the live valve that report coordinates, date, time, when it's open, that kind of thing?
Surprisingly, no. So the only kind of, because I have never operated any type of these like vessels. So most of my knowledge is from YouTube videos, and it's literally just a Y valve and it's shut and then secured. In some cases, it has to be removed. And that's really it. Some towns do actually pump out track exactly when and where the it pumps out. And the only kind of example is from town of East Hampton. I think that they are kind of the leading, example for pump out infrastructure on the East End.
Okay, figure through that. Thank you. Great job.
Next one is a video from Megan. She graduated in May.
I see. So our next speaker will not be present in person in the room. It's video. Megan Barrow.
Hello, my name is Megan Barrow, and I'm a master's student studying marine conservation and policy at Stony Brook University. And I did my internship with the New York State DEC in the Division of Marine Resources, Marine Fisheries Data Management Unit. Today, I want to explore a topic that operates quietly behind the scenes, but is fundamental to everything we do in fisheries science and management. That's data management. When we talk about connecting fisheries science to management, data is the glue that holds it all together. And for anyone that's familiar with R coding, here's a little pun for you. The glue that connects fishery science and management. For my internship, I interned with the New York State Department of Environmental Conservation in the Marine Fisheries Data Management Unit. My main project was to monitorize reporting workflows and data sharing, and I did this by building a compliance tracking system using R and SharePoint. This replaced the manual Excel process that they used, and now biologists and inspectors can see permit compliance in real time and spot missing reports more easily. I also built a simple Shiny app prototype for quota-managed species landings. It's not the full dashboard I envisioned, but it's still a solid proof of concept. Both projects centered on automation, accessibility, and making data more useful for managers. We usually focus on science or policy and fisheries, but what connects the two? That's data. Reliable, well-managed data is the glue that ties it all together. During my internship, I saw how workflow improvements like automation, dashboards, centralized reporting helped turn raw data into real-time decisions. Today, I'll show how tools like R, Shiny app, and SharePoint are monitoring fisheries data and making these faster, cleaner, and more usable for everyone involved. The main takeaway from today's presentation is fast and accurate data equals real-time, data-driven decisions. Fisheries data management has several vital components that ensure data is not only collected, but actually useful. There's data collection, which is from fishery independent and dependent sources such as landings, effort, and environmental surveys. There's storage. Is it stuck in a filing cabinet or part of a secure searchable database? There's data pipelines, which is cleaning, validating, and standardizing data from multiple sources. There's analyzing and reporting, and this is where raw data becomes meaningful metrics, summaries, and reports. And then there's data accessibility, and that's the final product that needs to be delivered in a format that scientists, managers, and policymakers can actually use, ultimately supporting timely, data-driven decisions. As Ribera Altamir et al. 2023 put it, this integrated system facilitates the transformation of heterogeneous fisheries data into standardized, analyzable formats and enables the interactive web-based visualizations that improve accessibility and usability for managers and scientists. Their figure illustrates how their entire process, from raw inputs to accessible data dashboards, can function as a connected workflow. I also want to acknowledge data governance, which is the access, permissions, data security, and maintaining integrity. It's about making sure confidential info stays protected and that edits are made by the right people. This is important in preventing catastrophes like what my office likes to call the Great Deletion of 2024, but data governance is a whole presentation of its own. Ultimately, effective fisheries data management ensures that data is accurate, accessible, and available in a timely manner, because even the best data is useless if no one can find it or trust it. Sustainable fisheries rely on good data. Poor data management can lead to misinterpreting stock health, missing environmental signals, and bad regulations that are either too strict or too relaxed. That's frustrating for scientists and a problem for fishers who miss out on economic opportunities. As Dr. Ellen Pikitch and her co-authors wrote, when we collect richer, more targeted data on key ecosystem interactions, it helps us evolve towards a true ecosystem-based management. This means tracking specific performance indicators and making decisions based on evidence so we can be both protective and precise, rather than defaulting to broad precautionary measures. Fisheries management is a balancing act, ensuring sustainable fisheries while supporting the livelihoods of communities that depend on them. This is done most effectively by data-driven decisions. From paper to progress. The progress is always changing, but over time we become more organized and less of a dumpster fire. Marine fisheries data management has made huge improvements over the last few years, where they are moving from paper to online reporting, which is more timely. They instantly scan documents and fill out metadata, and they have a centralized database, which creates a history and makes data more available. And they've created a QA/QC tool via R and Shiny, and this makes our data more accurate by fixing errors. Automation improved efficiency, but it also laid the groundwork for something even more important: real-time data connectivity. Here is part of a diagram from Bradley et al. 2019 showing how integrated data sharing systems are critical to effective fisheries management. I saw this firsthand during my internship. One of the workflows that I built was for the Shellfish Management Unit in Marine Resources, and by automating and centralizing a compliance report, we reduced the workload for their tech, and we made it easier for the field inspectors to know which shellfish dealers were missing reports. This had a ripple effect, and not only did it improve compliance tracking, but it also supported food safety efforts, since inspectors could easily trace shellfish back to who, when, and where. This is a great example of how better data connectivity helps both behind the scenes and in the field operations. Collecting data is just the beginning. The real power lies in how we connect or glue the data to decision making. From raw data to actionable insights. We bridge the gap using tools like SQL for storing and organizing data, R and R Studio for cleaning and analyzing, R Markdown and Shiny for reports and dashboards, and GitHub for collaboration on codes. This approach mirrors the Ribera-Altamir et al. 2023 article were described in their work using integrated platforms and web-based visualizations to turn raw data into accessible decision-ready tools. Imagine this. A fisheries biologist needs to catch trends for a specific quota-managed species, and they need it ASAP. Instead of waiting days for a report to be compiled, they can open up a Shiny app, choose a species, and see total landings data based on year, month, trips, participants, ecstatic, and it's all in a digestible, visually pleasing format. That is what I did my best to create in this internship. As you can see here on the left is an example of my prototype Shiny app, and on the right is a snippet of my shellfish compliance program, where the top half is reporting percentages by permit, and the bottom half is individual compliance, which is color-coded for faster recognition and tabbing for faster filtering. These tools help managers act fast and smart. When we share fisheries data, we don't just hand over spreadsheets. Our goal is to make it clear, usable, and actionable. That means every data set comes with context, what it represents, how it gets collected, and how it should be interpreted. Reports are readable and useful, and metadata preserves decision context. With real-time data and automated metrics, we can respond quickly, like closing a fishery the moment it reaches its quota. The value of this work extends beyond one report. It improves data quality, strengthens analysis, and supports smarter long-term management. As Christensen et al. 2011 report points out, good data infrastructure is key to long-term credibility and impact. We're not just collecting data, we're making it matter. Tracking more than just fisheries data, it's the data about the data. This chart shows the average lag between when a trip occurs and when it's reported, comparing paper reports to electronic trip submissions, or e-trips, from 2021 to 2024. You can see that the paper reports consistently show longer delays, while the e-trips are getting faster each year. But the lag tells us a story about the user behavior, the systems, and workflows. By tracking that kind of metadata, we can spot bottlenecks, improve efficiency, and strengthen data quality. As Christensen et al. 2011 emphasized, robust data infrastructure, including metadata and process tracking, is essential for long-term program credibility and informed decision-making. In other words, the more we understand how our systems operate, the better we can make our data timely, reliable, and useful for real-world fisheries management. Errors are inevitable, whether it's missing information, fat fingering, or back-end logic issues. That's why the Data Management Unit built a QA/QC system into a Shiny app, which flags potential errors in real time and allows us to catch issues early and ensure that clean data makes its way into the final reports. But even beyond automation, human oversight is still essential. For example, during my internship, I was reviewing annual compliance numbers for a quota-managed species, and something looked off. I dug into it and discovered that the SQL join was doubling certain entries, and it took some time to trace, but we were eventually able to fix it by adjusting the back-end views. This reinforced something that Dr. Young Chen in 2003 wrote about, how errors in fisheries data, whether it's in collection or processing, can directly affect the reliability of stock assessments and management outcomes. It's not just about getting the data fast, it's about getting it right. We've made major strides in improving how we collect, process, and analyze fisheries data, but there's always room for growth. Looking ahead, I'd like to focus on expanding Shiny tools, like getting my prototype to be a little bit more depth, automate more QA/QC processes, build new metrics, strengthen data connectivity between scientists, policymakers, and stakeholders to ensure that everyone is working with the same, most up-to-date information. Exploring predictive modeling, which could allow us to anticipate fishing trends and optimize management strategies before challenges arise, and offer more reporting training to get more fishers to report online, and we can focus on a better QA/Q system for the online reporting data. And all of this is because better data means better management. To wrap it up, data is the glue between science, management, and policy. Without effective data management, sustainable fishery policies wouldn't exist. Tools like R and Shiny connect raw data to decisions, and how we manage data now will shape the future of our fisheries. We're not just managing numbers, we're managing the story of our marine ecosystems, and better data equals better science equals better management. These are my references. Thank you, and again, my name is Megan Barrow, and I'm happy to take any questions by email. I also want to thank my mentors, Melissa and Bob, for all their help over the last few months. Thank you.
And if it's off, it's off. Hannah Mearns is next. Okay. And she's got her first slide up there. So we know what she's going to talk about. And there you go. Talking about whales.
Hi, I'm Hannah. I started my research project in the Thorn Lab in the fall of 2024, and I'm going to be talking to you today about evaluating baleen whale presence and habitat patterns in the New York, New Jersey Bight using Slocum gliders. So first, I wanted to give you an outline of what I'll be talking about. I'm going to start with my background. I'll get into my objectives. I'll focus exclusively on the New York Bight and past acoustic monitoring. I'll discuss my methods, my results, and the broader impact of my project. So my 4 study species are humpback whales, sei whales, fin whales, and North Atlantic right whales. These 4 species of whales are baleen whales in the order Cetacea, suborder Mysticeti. They're characterized by their large baleen plates for filter feeding, and they're found in a variety of habitats, including coastal, shelf, and pelagic waters. Most species of baleen whales were subject to intense commercial overexploitation and whaling, which severely impacted their populations. According to the Endangered Species Act in the United States, sei whales, fin whales, and North Atlantic right whales are classified as endangered. There are several distinct population segments of humpback whales that are classified as endangered, although not the distinct population segment along the Atlantic coast. But since January of 2016, humpback whales along the eastern coast of the United States have been experiencing an unusual mortality event. Studying baleen whale habitat is key to mitigating anthropogenic sources of risk, including vessel strikes and entanglements, and vessel strikes are one of the top current threats to baleen whales, and the New York Bight is extremely understudied. So my objectives were to learn passive acoustic techniques and process glider missions from the fall of 2024 to summer of 2025. I examined data collected from the New York Bight Ocean Indicators Project and funded research of baleen whales in proposed wind lease areas. I wanted to build off research from Dr. Catherine Gallagher and contribute to ongoing projects in the Thorn Lab. So the New York Bight runs along the south shore of Long Island from Maine to New Jersey, and it's economically and ecologically important. Compared to traditional foraging grounds like the Bay of Fundy in Maine for North Atlantic right whales, the New York Bight is extremely understudied. Here's a map of the New York Bight. You can see that it runs along the south shore all the way down through New Jersey. And in the gray areas indicated here, you can see shipping lanes headed into the port of New York and New Jersey, which is one of the largest ports in the country. So the New York Bight is a seasonally important foraging ground for large whales, and the return of prey species like Atlantic menhaden has been linked to an increase in foraging activity. Atlantic menhaden are a planktivorous forage fish species that were commercially overfished and disappeared from Long Island waters for decades. Their populations have recently increased after the implementation of an ecosystem-based management plan. Possible shifts in prey availability have led to an increase in foraging activity, including the return of Atlantic menhaden and other prey species in the region, which has made the New York Bight an important foraging area for humpback whales. So Slocum gliders are underwater autonomous vehicles. They are deployed for over a month. They fly in a sawtooth pattern through the water column along a predetermined course. They'll surface every few hours to communicate with scientists out of their tail here via satellite. Passive acoustic monitoring is a relatively new technique to be implemented on gliders. It's traditionally used on buoys, and the Thorn Lab uses gliders from Stony Brook University and Rutgers University. The Stony Brook Glider project grew from the New York State Department of Conservation's goal to monitor the New York Bight's health. The gliders collect oceanographic data, including latitude, longitude, and depth, among other things. These gliders are also equipped with DMON, which is the digital acoustic monitoring instrument designed by Woods Hole Oceanographic Institution. So my methods were to use the Low Frequency Detection Classification System, or LFDCS, to process the acoustic files, analyze whale calls, and assess presence and absence according to thresholds from Davis et al. 2017. So I first would download the acoustic files from the glider, and these acoustic files had to be processed with the LFDCS twice, once for fin whales at a lower frequency, and once for humpbacks, seis, and North Atlantic right whales. I then analyzed the pitch tracks with the LFDCS, confirmed daily presence and absence for each species, and did a manual confirmation of each species. I then matched the whale and glider file in RStudio, and it's only after the sixth step that analysis of the acoustic files can take place. Although the manual confirmation isn't used in the analysis of the acoustic files, it is important because using a confusion matrix in R, you can assess the efficacy and the accuracy of the LFDCS compared to the manual analyst's confirmation of each species. And this protocol was written and developed by Dr. Catherine Gallagher. So I'd like to show you a few spectrograms. This is a fin whale spectrogram. Along the y-axis here, you can see frequency, and along the x-axis here, you can see time. Everything in the middle are background noises and acoustic detections. The white blips that look like the burning head of a match are all fin whales, and the little squiggly shapes in some of the calls are the pitch tracks that I just referred to. Fin whales typically occur at 20 kilohertz, and they occur in these interpulse patterns that can go on for hours. These are humpbacks. You can see they are much more varied in frequency, as there's some up here and lower in frequency. These are sei whales. You can see 5 pretty distinct calls along the bottom here with 1, 2, and another 2 over here. They typically occur along the bottom of spectrograms, and the 2 that are grouped are called doublets because there's less than 3.5 seconds in between each calls. And doublets consist of 2 calls that are in a down sweep, meaning when you read it from left to right, they're in a downward trajectory. This is a North Atlantic right whale, and you can see it's about in between the 100 to 300 frequency range. So I processed 3 glider missions from October of 2024, January 2025, and May of 2025. I contributed to the broader pool of passive acoustic data in the Thorn Lab by processing these 3 missions. I made a spatial plot of the 3 missions that I processed. You can see in the purple mission is May, green is October, and blue is the January mission. I then overlaid the spatial plot of where the gliders went with the cumulative amount of detections per species along the route. You can see there are a ton of humpback whale detections, although there's noticeably less in the May missions than there are in the January and October missions. I did the same thing for sei whales, and you can notice this little clustering right here in the May mission, although there's definitely less humpbacks, less sei whales than there were humpbacks. Similarly, for North Atlantic right whales, there's not a lot. It is interesting to see that there are some groupings of North Atlantic right whales here and here in the May mission. North Atlantic right whales are not typically seen in the New York Bight during the summer months, although Dr. Gallagher and other scientists have seen in 2024 spikes of North Atlantic right whales in the New York Bight during the summer months. There are papers in review, and more research is needed to understand if this is a growing trend with North Atlantic right whales. For fins, you can see that they're found along every glider track, noticeably less fin whale detections in the second half of the May mission. These grid cells account for spatial and temporal autocorrelation by normalizing the detections by distance traveled and by counting unique detection days instead of every call. Autocorrelation occurs when observations are close together in space and time and not independent of one another, but that doesn't necessarily signify a pattern. Spatial autocorrelation is pertinent because if a whale is detected in one grid cell, it's more likely to be detected in a neighboring grid cell. But this doesn't necessarily mean that whale was present in both grid cells. The colors in the color bar on the right hand over here signify the detection days per kilometer surveyed. And the grid cells account for frequencies and relative distances the calls travel for each species, so the size of the grid cells will change per species. It is important to note that since I only processed 3 missions, there's only 1 mission per season. And noticeably, you'll see in summer, it isn't even a full mission, it's the second half of the May mission. This depicts sei whales. You can see there's a lot of that muted yellow color indicating not a lot of detection days per kilometer surveyed. Here's North Atlantic right whales. You can see a bit more variability in the spring over here. And lastly, here are fin whales. These have the largest grid size, as you can see, because they call at the lowest frequency. The calls of fin whales travel for the longest amount of time underwater. Passive acoustic monitoring on UAVs has proven to be a technique that can prevent vessel strikes. Gliders can be effective monitoring platforms that can enhance global oceanic dynamic management. And due to the high amount of vessel traffic, large ships, and the speed of ships, there's a high risk of vessel strike to large whales. Studying whale presence can inform policy initiatives and management, especially in a high vessel traffic area like New York. Thank you to my mentor, Dr. Thorne, and the entire Thorne Lab, as well as Dr. Gallagher, who trained me on passive acoustic monitoring. Thank you to Carl Safina and Patricia Paladines for their ongoing support. And a special thank you to Emma Pierce and Zach Hoffman for their help troubleshooting with R. My project would not have been possible without all their help. Thank you. Any questions?
I'll take it away. Well, why don't you tell us a little bit more about how the gliders went?
Scientists determine the course the gliders travel. Their course can be altered. They don't travel at very high speeds. They're about like 4 to 5 feet long. They get deployed off of boats and they travel sawtooth, so they go up and down and obviously horizontally in the water column. They have little clicks. If you listen to the spectrograms, sometimes you can see and hear the glider clicks. Yeah. I wasn't super involved in the glider process. Yes.
I was gonna ask, you may not know the answer, what other data was the glider collecting at the same time? And are you using that, or are there any plans to use that to relate it to the whale locations?
I'm not sure if there are plans to use it to relate to the whale locations. I think it's more about understanding the oceanographic like details of where the whales are present, because maybe depth or salinity influences where the calls are, where the whales are. The gliders collect a whole host of oceanographic data. Off the top of my head, I can think latitude, longitude, depth, salinity, temperature, chlorophyll. Yeah.
So in your workflow diagram that you showed early on, one of the steps was a manual confirmation.
Yeah.
The AUVs out there operating independently, how do you verify that the whales you think were there are actually there?
So the manual confirmation means going through the spectrograms for the 10th, 20th, and if applicable, 30th days of the mission. And you look at it without pitch tracks, and you as the analyst, according to the thresholds from Davis et al. 2017, determine if any of the species are present in those days.
Probably based on agency signature.
Yes. Yeah.
Thank you. You got some questions there? Okay. Jordan? Okay, Jordan's gonna talk about cold stun sea turtle stranding. Okay. Just make sure.
Hello everyone, my name is Jordan Medina and the title of my MCP project is Surges in Cold Stun Sea Turtle Strandings in New York, a 5-year review from 2020 to 2025. So just to go over my agenda for today, I'll be giving a brief introduction about the topic of my project, which is cold stunning in sea turtles. I'll be going over my project outline, I'll be also giving a short review on Maxine Montello's manuscript that she wrote, since I used a portion of it for my project. I'll be going over my methods, my results, my discussion, and then I'll go into my concluding thoughts. So getting off with the introduction, first off, what is cold stunning? Cold stunning is a physiological temperature shock that is similar to hypothermia. This usually occurs when water temperatures are at or below 50 degrees Fahrenheit, 10 degrees Celsius. And basically what cold stunning does is it alters sea turtles' ability to function. This means that it can affect their swimming abilities, their circulation, their organs, and even in severe cases can affect their shell, skin, and their eyes. Sea turtles can be found here in New York. Most commonly, they're found in the Long Island Sound and Great Peconic Bay. Usually, we see juvenile and subadult sea turtle species. And the three main types of sea turtle species that we see here are the Kemp's Ridley sea turtle, which are currently listed as critically endangered under the Endangered Species Act. And you can see the picture in the top right corner over here. And then the second type is Atlantic green sea turtles, which are currently listed as threatened under the ESA, and it can be seen in the middle picture. And then loggerhead sea turtles, which are also currently listed as threatened under the ESA and can be seen in the bottom right photo. So getting into my project outline, I decided to do an internship with the New York Marine Rescue Center, which they rescue and rehabilitate cold stunned sea turtles here in New York. I analyzed this research paper written by Maxine Montello, who is the executive director at the New York Marine Rescue Center. And Montello and her colleagues had actually predicted that there would be an increase in cold stunned strandings here in New York. So basically, the topic of my project was to see if there was any evidence that supported their predictions. So I organized and analyzed the New York Marine Rescue Center's stranded cold stun data from 2020 to 2025 to see if it had any support or evidence that for their predictions that they made in the manuscript. So getting into Montello's manuscript, first off, cold stun strandings have actually been recorded since 1924 here on Long Island. Major cold stunning events have also occurred between 1985 and 1987. But in Montello's manuscript from 1998 to 2019, they actually recorded a total of 510 cold stun sea turtles. Now, this 510 total was with 5 restrands. A restranded turtle is a turtle that had originally stranded, was picked up by the New York Marine Rescue Center, rehabilitated, and then released. And that same turtle ended up restranding back in New York and picked up again by the rescue center. So even though it was 510 with the restrands, this left 505 individual cold stun sea turtle cases that the New York Marine Rescue Center had documented during that time period. And so getting into some of the data that they had documented, in the bar graph here on my left, Montello and her colleagues had documented the total amount of stranded cold stunned sea turtles from 1998 to 2019. And each individual bar represents the total amount of stranded sea turtles found within that specific year. And then the different colorations represents a different sea turtle species. So the black and white stripes are the hybrids, are called hybrids because these were sea turtles that were identified as cold stunned by the New York Marine Rescue Center, but the species was unknown. The gray color is for Atlantic green sea turtles, the black spots are for loggerhead sea turtles, and then the color black is for the Kemp's Ridley. So as we can see from this graph, in the year 2015 and 2019, these had the largest number of cold stunned sea turtles recorded over that 21-year period. And over here to the arrow pointing to the pie chart, Montello and her colleagues just wanted to display kind of the total percentages for the sea turtle species, and they divided it by the 4 species that they had laid out within this bar graph. And as we can see, the Kemp's Ridley species have the largest percentage and are most commonly known to be stranding here due to cold stunning. And then while they also looked at the total number of stranded cold-stunned sea turtles, they also wanted to look into their final dispositions. Final dispositions are important for managing and gaining more insight on each individual sea turtle species populations. So they did this by separating them into 3 separate pie charts. The LK pie chart over here represents the Kemp's Ridley, CM represents the Atlantic greens, and then CC represents loggerheads. And they divided the pie charts into 3 by the 3 main dispositions that they usually record when a sea turtle is stranded. So DOB means died on beach, DIH means died in house, and then if they were released. And the number over here in the corner just represents the total amount of stranded cold-stunned sea turtles that were found for that specific species among the 3 dispositions. So as something to note is that their release percentages are either the same or a little higher than their DIH percentages, which gives a positive outlook on the New York Marine Rescue Center and how they're rehabilitating and releasing their cold-stunned sea turtles. And so now that we have some background on what Montel and her colleagues did, let's get into what I did. So, like I said earlier, compiled, analyzed data from 2020 to 2025, following kind of the same data analysis that Montel and her colleagues had used in their manuscript. I analyzed this data by individual animal case. So in each individual animal case, each sea turtle gets a New York number by the New York Marine Rescue Center. The exact date they're stranded is recorded, their species type, along with their longitude and latitude coordinates where they stranded, whether they were alive or dead when they stranded, their standard carapace length, their weight, and then their final disposition is recorded. And then just to give you guys an idea of what it would look like in my Excel spreadsheet, this is an example of just one singular animal case. I did this all the way from 2020 to 2025. And something that I thought would be cool to add was their SCL and weight at the time of their release, just to see how much they grew over time from when they had originally stranded. And as you can see, this guy was living the good life at the rescue center. So let's get into my results. So I kind of pretty much did the same data analysis that Montello had laid out in her manuscript. So I calculated the total amount of cold-stunned sea turtles from 2020 to 2025. This amounted to a total of 397 cold-stunned sea turtle strandings, and this is with 3 restrands. And each color represents a different species. And then I also put the year, and then this would be the season for the 5-year period. So the Kemp's Ridleys are in blue, loggerheads are in red, Atlantic greens are in green, and then yellow are the hybrids. And as we can see, 2022 and 2024 had the largest number of stranded cold-stunned sea turtles over the 5-year period. And these numbers are significantly higher than the numbers that Montello and her colleagues had previously recorded in their manuscript. And then I also did a pie chart just displaying the total percentages calculated for the different species type. And it does correlate with what Montello and her colleagues had documented, that the Kemp's Ridley sea turtle are still the most commonly found sea turtle to be stranding here in New York due to cold stunning. I also did do their dispositions as well. Here, as we can see, something to note is that all of their release percentages are higher than their DIH percentages, which is also a positive increase and again, a positive outlook for the New York Marine Rescue Center and how they're rehabilitating and getting to release their sea turtles. And again, the number in the bottom just correlates to how many sea turtles were calculated among the 3 dispositions for that specific animal species. So what does this mean? So I found that my data does support Montello's manuscript and their predictions within the research article. I did calculate that there were 77% of all total sea turtles over the 21-year period just occurred in the last 4 years. And as I previously mentioned, 2024 did have the highest number of sea turtle stranding since 1980, with 160 individual cases, which is a huge jump from, I think there were 98 that Montello had documented in her manuscript. So that's a really huge increase since 2019. And when I combined both data sets, this amounted to 904 individual cold stun sea turtle cases, and just 43.6% of those cases occurred within just the last 4 years. So that's another big indicator that is a significant increase. So what could be causing the sudden increase? It could be a number of things. It could be a rise in sea surface temperatures, which is causing a lack of seasonality for sea turtles here in New York. It could be that the general public is more aware due to educational outreach efforts from the New York Marine Rescue Center. So we don't inherently know what the direct cause is, but we know that this increase is occurring. And then my overall concluding thoughts. Sea turtles in New York are facing an increase in cold stun strandings. The New York Marine Rescue Center has updated their protocols for allowing for more live rescue responses. And of course, this research is important just because sea turtles are a keystone species and they're indicators for positive ecological health within our marine environments. There is more research that is needed to better understand what other additional environmental factors could be contributing to this sudden increase. And then not only did I get to do data analysis over the summer, I also got to participate in sea turtle animal husbandry, water quality, and of course, I got to participate in releasing some sea turtles and seals over the summer. So just wanted to highlight some of the cool things that I got to do with the New York Marine Rescue Center. And then if you guys want to get involved or follow along, you can follow them on Instagram, TikTok, and here's their website. And of course, the stranding hotline if you do see a stranded marine animal. And then my references, and then I would just like to thank the New York Marine Rescue staff. I'd like to thank Maxine Montello for being my internship mentor. I'd like to thank Bradley Peterson for being my SBU mentor, and I'll open the floor to questions.
Can you explain how increasing sea surface temperature could potentially increase cold stun?
Yeah, I read in a recent article, I think that Maxine had cited in her manuscript that if sea surface temperatures are staying warmer for longer during like late October into early December, because that's usually when cold stunning season occurs, that it could cause a lack of seasonality for these sea turtles, indicating that they think the water is still warm, and I guess indicating that they will stay longer because the water is warmer and they won't have enough time to make it out when it gets cold, if that makes sense.
They just don't realize they're
Yeah, they just don't realize they're supposed to go. And we're like, go, gotta get out of here. Yeah.
I know it's tangential to your study, but I was surprised to see hybrid sea turtle. What can you tell us about hybrid sea turtle?
I don't know much about it. I actually was asking around at the New York Marine Rescue Center, the staff, but they were just saying that, yeah, it's just a sea turtle with the that they had recognized, but they didn't know what species it was. So that's kind of what I got from it, but I don't know much about hybrid sea turtles actually. Yeah.
How does New York's Rescue Center success rate compared to other programs?
Their success rate has been pretty well off, especially because of, again, all the sea turtles that they've rescued this season, but their educational outreach, and I know their social media team is really big on getting out into the community and informing people. So I think having that is a big contribution to why they're also receiving a lot more turtles this season. So that's what I'd say.
Great, thank you. Thank you. Ryan O'Keefe is up next.
Oh, yes.
Nice. Okay. So Ryan will be talking about mapping estuarine habitats.
Good afternoon, everybody. So today I'm just going to be going over the NOAA College supported internship that I did over the summer, which was mapping the estuarine habitats and the plant communities at Wacoit Bay's National Estuarine Research Reserve, which is located in Falmouth/Mashpee, Massachusetts. So this internship really stressed the importance of the preservation of salt marshes as well as estuarine habitats. Estuaries and marshlands have been degrading over the past century. In a study that was conducted in the 1970s, approximately 25% of salt marshes were destroyed in the US just between 1922 to 1954, primarily due to industrialization and settlement. And so this is important because approximately 129 million United States citizens live within coastal counties, which equates to about 40% of the US population. These habitats are crucial for marine life, birds, and upland forests, as well as the protection and health of us as humans. So out of this study came the Coastal Zone Management Act of 1972, where its goals were to protect, restore, and enhance where possible our nation's coastal zones. And these shorelines, estuaries, and marshlands are all hosts for economic and ecological resources, as well as providing recreational and cultural value as well. They are vulnerable to anthropogenic activities, such as developmental pressure, as well as climate-related threats, and amendments throughout the years have really emphasized coastal erosion as well as sea level rise. So out of this policy came the National Estuarine Research Reserves, and they were established. Today, there's about 30 different coastal sites designated as these reserves, and they're found all over the country, as well as territories in the United States. And the four main focuses of these reserves are stewardship, research, training, and education. And so these systems were created to establish the designated reserves, create guidelines for research, and then provide the financial support to these areas of interest. They also act as living laboratories for the study of climate change, pollution, human activities, and they provide a baseline for environmental monitoring. So at each of these NER sites, a habitat map is required, and it's created using aerial imagery and modeling. And with this comes accuracy assessments that are conducted with these maps to make sure that, given the remote sensing of them, sometimes they can't always be as accurate, but so we'll do an accurate assessment to provide some accuracy to these maps. They help track the trends of vegetation, assess the estuarine health, as well as provide support for future research. And these accuracy assessments or reference points are visited within the field and are solely used to assess the habitat map and not to make any changes or edits to the map itself. So after the accuracy assessment is completed, the map, along with the assessment itself and any data involved with it, is uploaded to the centralized data management office, which is accessible by the public via website. So at a minimum for these accuracy assessments, they require the collection of in situ data using a real-time GPS, and the habitat categorization, which is from the National Estuarine Research Reserve classification scheme. It is recommended to use the stratified random sampling method, and 50 or more points be categorized in each of these classes. So the data collections include the site location, any observations and measurement, timing of the data collection, as well as information collected and any photos. And so here's just a map that shows the Wacoit Bay's National Estuarine Research Reserve. It's located on the Cape in Massachusetts. And these different colored areas are all actual properties of the reserve. However, for the course of the internship, we also did accuracy assessments on points that were not in the actual property, but are considered estuarine habitats. So in 2024, the NOAA Office of Coastal Management conducted a modeling using the aerial imagery to model 13 separate habitat classes in the estuary. And for this, they used the pixel color and elevation from the aerial imagery. So here's an example of the aerial imagery that they provided, and based on this, they were able to map them, the reserve into the 13 different classes. And I'll have a map of that shortly. So for the 13 different classes, I split them into 3 groups to just kind of go over. One was high marsh and low marsh, and really the driver for these is vegetation type. So Spartina alterniflora and patens, Disticula spigata, and Juncus gerardi were the main habitats or vegetation to classify into these habitats. And then low marsh was if the area was prone to constant flooding, and the main vegetation type was also Spartina alterniflora at about greater than 75 centimeters of length. The other vegetations were salt shrub, which was mostly Iberfrutescens and Baccharis, native brackish marsh, which was pretty much mostly cattails, and then invasive Phragmites was the other class. And then lastly, pretty much sediment and or water, so sand, rack, where the dead vegetation usually comes up from the high tide, mud flat, die-off depression, natural pools, and then open water. So here's an example of 4 of the main areas within Wacoit Bay's Research Reserve. And you can kind of see the different habitat delineations based on the colors, with open water being the primary habitat as far as square meters. So during the internship, the general goal was to create at least 50 accuracy assessment points in each of these 13 habitats, and then conduct field work on these accuracy assessment points on the generated points. And so to do this, I used the Create Spatial Sampling tool within ArcGIS Pro, which ideally was to generate these 50 points and avoid any sort of clump points. So the goal was at first 50-meter spacing. However, there was issues with the habitat sizes for some of the classes. So we had to reduce some of the numbers of the points as well as the general spacing. So for the stratified sampling, some of the spatial points were not 50 meters apart. So for the final assessment, we settled on 30-meter distances with rack and mud flat being a little bit less than 50 points per class, and then joining these points with the habitat map to bring over the habitat class. Here's just a chart that kind of shows the percent total in area. Open water is about 84% of the entire habitat map. If we had tried to do a stratified random sampling based on the stratum area, it would put a majority of the points in there, and we wanted to make sure that each class had at least 50. So for the methods throughout the internship, I had used an iPad or a personal cellular device, which was paired with a R1 Trimble device, GPS external device, which gave me about less than 1 meter accuracy while I was in the field. And I used ArcGIS field maps in order to track the points and conduct the surveys, as well as different vehicles, kayaking, boating, hiking, trucks, etc., for whatever we could use to get to that field point. And so while I was in the field, this is an example of what the form looks like when I was collecting data. So for an incorrect habitat, the class name is what it's classified as in the habitat map. Is habitat correct was false. What the proposed correct habitat is in that area, the level in which I was able to view this from. So for this one specific example, I wasn't able to get too close to the point just due to the terrain. And then any notes such as the accuracy of the GPS, unfortunately, this one was not too good when I was out there. So, and any other notes that I'm able to get. And so an example for the correct habitat, this is a salt shrub habitat. It turned out to be true when I visited the point, and I was able to get right exactly on the point. So it was a walkthrough standard polygon, and then the accuracy of the GPS. For almost all of the open water points, we had interpreted those in the office just because it was pretty certain that what they had labeled them as open water was correct. And so for the results, we were able to generate this map. The triangles mean that that's a point that I was able to get to, and if it's green, it's the habitat was correct when I visited it, and if it was a red triangle, it was incorrect. The black stars are still unverified at this point, but they will be soon classified and assessed. And also, an error matrix was able to be generated from this. On the left is what the habitat map was classified using the aerial imagery, and then up top is what I was able to classify as. So We were able to generate some statistics for this. The kappa statistic is 0.843, which based on the NOAA guidelines and standard operating procedures is pretty good, but we still have some more points to classify. And so the broader impacts is that the mapping and accuracy assessment allows these sites to track the short-term variability and long-term trends. It enhances the integration, dissemination, and discoverability of this data, and then strengthens the scientific foundation for where research, restoration, and resilience planning and policy decisions are based. And these are really important areas because estuaries are carbon sequesters. They help buffer storm surges, reduce coastal erosion, and then protect habitats for organisms for both ecological and economic value. These are my references, and take any questions. Yes.
I know this is mostly about assessing like the accuracy of this methodology, but when we talk about salt marshes a lot, you brought up, it kept saying invasive Phragmites, which obviously it's invasive.
Yes, yeah.
But there is some newer evidence that shows that the Phragmites is better at storing carbon than our native salt marsh species. And so when we talk about ocean acidification, sometimes like, I don't know, the question I guess is, should we even just keep
Referring to as invasive, like it is invasive, yeah.
We're bad at it. Do we have to always hate on Phragmites, I guess?
Yes, yeah. I don't know, I guess, about the sequestration of it. Like you said, this was pretty much just to map it. But there were a lot of instances where it was mapped as one a different habitat, but when I was physically there, it was invasive Phragmites. So I don't know if it was just inaccurate or if there, it is breaching on different habitats. Yes.
There are certain habitat types that did better reverse in your accuracy assessment aside from open water.
Yeah, so I'd say a lot of the first group of the vegetation, there was a lot of inaccuracies with it, and I think that's just due to the fact that from an aerial imagery point of view, it's hard to determine exact species of those vegetation types. The third group with the sand, mudflat, natural pools, those were a lot more accurate. The rack, though, was not always very accurate, and it can kind of be a sort of transitory habitat, so it was a bit inaccurate at times.
Other questions? Okay, thank you very much.
Thank you.
Thank you. Okay. Okay, next up we have Lauren Russell, expanding education about seals and their interactions with humans.
Hello, everyone. So yes, I did my project on expanding education about seals and their interactions with humans. So as we all know, Long Island's proximity to water coincides with the presence of various marine species, but unfortunately, residents may not be fully aware of the abundant species that inhabit our waters, especially seals. So to try to identify this knowledge gap, my project aimed to expand the knowledge of seals on Long Island and the impacts of human interaction. So while there are 3 families of pinnipeds, I mainly focus on the phocids or the true seals, and they're the only ones who are found in the North Atlantic. And historically, the harbor seal was the only species that frequented Long Island waters, but more recently, the gray seal has had an increase in abundance. And also the harp seal is an Arctic species that has seasonal migration south to eastern Canada and here in the northeast US. Their abundance has also been increasing, which can be due to a combination of factors, but unfortunately the most prominent is climate change. So while the harbor gray and harp seals are the 3 most common species seen, there are 2 more that have been seen in the past, which is the ring seal, but it is considered the rarest species with only with having the last stranding in 2006, and then the hooded seal is the second rarest species with only 4 strandings in the last 10 years. So these are just some images of the seals you would see here in New York. So that's a juvenile gray seal, a harbor seal, and then a juvenile harp seal. And then we have the 2 rare ones, the hooded seals and ring seal. So when seals start to occupy New York waters, this is considered seal season, and it starts in the late fall and peaks around March and April. So the harbor seals arrive around October, the gray seals arrive around November, and then the harp seals arrive around January. And the seals that are on our beaches are typically pups or yearlings, but juveniles and adults are present as well, and they do tend to stay throughout the summer. And when seals come onto land, it's considered hauling out. So they haul out onto the sand, onto docks, boulders, just anything to rest or socialize. And it's important to note that they can and will remain in one area for multiple days. And when they're disturbed by human presence, seals will become more alert, they'll vocalize, they'll bare their teeth, and then flush into the water. So all marine mammals are federally protected under the Marine Mammal Protection Act of 1972, or the MMPA. And this prohibits the take of marine mammals, which includes the harassing, hunting, capturing, killing, or attempting of any of these actions. And it is also stated that viewers must stay at least 150 feet away from the animals, and they can serve up to a year in jail time or a pretty hefty fine if they violate the MMPA. And a study was done and it found that the most frequent types of human interaction in New York are entanglement, harassment, and vessel interaction. And the study occurred from 1996 to 2021 and found that there were 1,407 seal strandings in New York, and 135 of those had human interaction observed. And they found that entanglement was the most common with 68 cases, and harassment followed with 41. So this is just some images of what entanglement looks like. It's typically around the neck, or it could be the torso. And as you can see, it's fishing gear, it's lines, maybe some buoys. And then the middle image just shows how deep the lacerations actually get into the seal's skin. And then harassment, in a 1994 amendment was described by the MMPA. And it entails any act of pursuit, torment, or annoyance which has the potential to, and they broke it into level A and level B harassment. So level A is injure a marine mammal or marine mammal stock in the wild. And then level B is to disturb a marine mammal or marine mammal stock in the wild by causing disruption to behavioral patterns such as migration, breathing, nursing, breeding, feeding, or sheltering. And these are just 2 images of what is considered harassment. The first one, obviously, touching a seal is considered harassment. But the second one, even just letting your dog get too close, is classified as harassment as well. So for my motivation, my interest with seals sparked during my internship at the European Rescue Center last year. And I learned that a large amount of people do not know we have seals on our beaches. And since I'm a native Long Islander, I have seen seal viewing guideline signs at many beaches, but I overlooked their effectiveness until this opportunity. And I believe by correctly informing the public, they can help us fight for their protection in an effective way. So for my internship, I interned with the New York State DEC. And in 2020, COVID produced the need for the DEC to create seal viewing guideline signs, and it describes how to safely view seals. So originally, 83 signs were placed from Breezy Point, Montauk to Orient Point, and they were hung at beach entrances where seals frequently hauled out. And for the first time, the signs were reassessed in January of 2025. We went to 5 new locations, so in total, we visited 88 locations around Long Island. And within those 5 years, many of the signs were missing or could not be read anymore, so we had to replace them. And then once all the locations are visited, I categorized them into 5 different criteria, which was missing, bleached, faded, good, and then new. So this is an image of what the sign looks like. It's very vibrant with the blue and yellow. It says how far to stay away from the seal, what not to do. Again, the stranding hotline number, everyone should put that on their phone, just have it. And then the 3 most common species. So then I picked back up in the spring semester where I led a level 1 seal advocacy lecture in collaboration with the Rescue Center and the DEC. And this was to just give the public a chance to learn more about the MMPA, what seals are here, how to determine the species, how to view them, who to call, and all details of human interaction. And this presentation aligned directly with my main goal of my project, was just to introduce or expand the public's knowledge of seals in New York. And then I decided to create 2 maps in ArcGIS Pro. One was just to show the conditions of the sign at each location when I went in January, and the second is a newly updated map where all the signs are currently placed. And then I obtained human interaction data from the Rescue Center from the 2020 to 2025 seal seasons. And for each year, I broke down the cases into harassment, entanglement, combined, hooked, boat strike, and illegal take. And then I wanted to see if a sign was present at each human interaction case, so I just cross-referenced GPS locations. And then finally, I made, in collaboration with the DEC, a seal education pamphlet with all the key information needed, as well as I helped design a seal education sticker. So these are the sign categories. Missing is obviously is no longer there. Bleached, the sign was completely white. Faded, it was faded, but you can still read a little bit. Good, and then a new sign. So this is a gradient of the types of signs we saw. You can see it's missing. Bleached, that was the worst sign condition we saw at Illinois Avenue Long Beach. And then we went to faded, good, and then obviously a new sign where everything's vibrant and you can read everything. So this was the map of all the conditions of the signs. You can see it's kind of varied across the island. In Orient Point and up on the North Fork, it's all yellow, which is the faded signs. But if you break it down, if you go to Long Beach, almost all of them were missing, and most of them, or the other three, are faded. And then if you look at East Hampton, all of them are missing. And this is interesting because obviously we replaced all the signs, but as of June of 2025, a DEC employee went out, just happened to go to 2 Mile Hollow Beach and Egypt Beach, and the signs have already been taken down and replaced with East Hampton's own signage. So we're unsure as to if all the signs have been taken down already, or if it's just those two, but they replaced it because I compared pictures with either the RIP current pamphlet or the new parking mobile sign. And then this is just a breakdown of all the different conditions. So as you can see, missing was the highest. Bleach was pretty low, which was good. Faded was 25 signs, and then good, and then new. So in total, of the 83 original signs, 64 had to be replaced. So this is now the updated sign of map of where all the signs are. Like I said, it might be changed now due to East Hampton taking down the signs, but hopefully they're still in the same spot. But this is the most updated map of where all the 82 signs are. There were 5 locations we couldn't replace just due to not being open to public or just not a good place to hang them. So this is a completed list of where all those signs are. So it's a good amount, but it's good to have them out there. So now for human interaction cases, like I said, I broke them down into different areas. So we already talked about harassment, but one case was like rope was found on the beach and used by a patron to drag the seal into the water. Entanglement we spoke about, and then combined, I categorize it as the seal was entangled, but the public disentangled it themselves, which is considered harassment. Hooked is just there was evidence of a fishing hook somewhere in the seal's body. Boat strike was evidence of boat strike. And then illegal take is someone removed the seal from the beach without contacting one of the federally permitted stranding response organizations first. So an example of this was someone picked up a seal from the side of the road and brought it to Sweetbriar Nature Center. So from 2020 to 2025, there were 70 human interaction cases of seals in New York. And as you can see, from 2020 to 2022, harassment was the highest. And we believe this is just due to COVID. People were on beaches when they typically weren't, and probably seeing seals for the first time and not knowing how to properly view them. And unfortunately, harassment occurred. But luckily, it did drop down in 2023, and it's on the increase now. But now entanglement is on the rise, which is just interesting to see how everything is shifting. And then this is the same graph, just showing by species. So you can see that across the board, gray seal, unfortunately, is the most common species that has human interaction occurring. And then for the GPS locations, I used the GPS location of where the case occurred and compared it to if the beach had a sign placed. And unfortunately, for the most part, no. There was no sign placed at the beaches that harassment or human interaction was occurring. But it was interesting to note that for 2025, there were 10 cases. These all happened after the signs were replaced, and 7 of the cases had signs directly at that beach, while 3 didn't. So while harassment still occurred while signs were there, it might have given the public a better chance to see the hotline number and call them more effectively and get the situation handled faster. And then I found that there's 3 beaches that have the most common human interaction, which is Smith Point County Park, Shagwan Point Montauk, and then Montauk Point. Smith Point has 3 signs up right now, but they're all closer to the campgrounds, and all these cases happen further down by like cut 2 and 3. So maybe it would be beneficial if more signs were put down further. Shagwon has no signs placed, so this might be another area to look into. And then Montauk Point does have 2 signs up, so I think that's a sufficient amount because it handles both sides of the point. And then this is my SEAL education pamphlet. This is like the backside of it, but it has like all frequently asked questions. Again, the hotline number, the 2 rare species, and then flipper files that you can share a sighting of a live non-distressed turtle or marine mammal. And then this is the inside of it. So it has the 3 most common species, the updated map of what a sign looks like, what human interaction is, signs of harassment, and then if you think a beach needs a sign, you can send an email to that address and they can work with you to try to get a sign placed there. And then this is what the sticker looks like. It's still in production, so I don't have any today, but I do have pamphlets in the back for everyone to take one if you like. So again, it's the same QR code to scan for responsible viewing guidelines, and with the slogan, 150 feet away is the best place to stay. So I just want to give a huge thank you to the DEC for allowing me to do this project, especially for Catherine and Megan for all their help, and for Kyle for driving me 40 hours across the island in the 2 coldest weeks of the winter, and for Sam helping me out for the pamphlet, everyone at the Rescue Center for allowing me to use their human interaction data, and then for all of SoMAS, thank you to Leslie Thorne for being my mentor, and for the MCP program allowing me to do this project.
Good job. Any questions?
Yeah.
So you mentioned in the beginning, like, you know, when you were younger, going to the beach, and maybe you just kind of like figured you get the sign, but they didn't mean that much to you. Do you think there's a more effective way than just posting signs to reach the people who are just kind of going there and they just look at the sign and they don't really read into it? Or do you think it's just like constantly maintaining the signs to make sure they're there?
I've been trying to think about that. I think keeping up with the maintenance of them might be best. I was trying to just brainstorm other ideas that could happen, but as of now, I think just keeping up with the maintenance of them might be the best shot.
I agree that if they're like, you know, the more faded they are, the less likely you're gonna get people look. So if you have that, like, you know, there's that bright green part of it, kind of catches your eye.
Yeah.
So I think, you know, if there is constant maintenance, I think it'd be effective, but you know, it's like you said, not everyone is gonna take the time to read it, unfortunately.
Yeah. Yeah.
Do you coordinate with the towns at all when you're putting up these signs? Because you were saying like East Hampton took them all down.
Yeah. No. Like just like any like hotspot beaches that had a lot of haul outs. It was just any beaches like that. Yeah, it was no coordination. But I do think that if they keep taking down the signs, it might need to happen and figure out why they keep taking them down. But yeah, no.
Maybe now's a good time.
I know. Yeah.
Yeah. Yeah, it looked like there's limited room on
Yeah.
those posts to put signs, and they're gonna prioritize their signs.
Yeah, that's why we couldn't replace some because there was just no room left. So
Yeah.
yeah.
Okay. I think we need to move on to the next speaker. Great job. Thank you. I love the sticker.
Thank you. Hannah is actually going to be on Zoom.
I hope so. Okay.
Hopefully is already on Zoom. Yeah, second. Allow, yes. All right.
Okay, our next speaker is zooming in.
Yeah. Hannah, you should be able to share your screen now. And you're still muted. And we can't see you. We'd love to be able to see you as well.
Hello, can you hear me? Okay, let's see if this is working now.
We hear you, so that's a good start.
Am I there? Can you see me now?
Let's see. Yes, we can see
Is
you.
it sharing? Okay, good.
I switched our camera around so you can see us.
Hi, everyone. I'm so sorry to not be there with you in person. Let me make my view better. Let's see if that's working.
That looks good.
Can you see it? Okay, great. Hello, friends. I'm sorry to not see you. It's nice to see you virtually. So today I'm talking about my capstone. For my capstone project, I conducted a content analysis of comments submitted as part of a proposed National Marine Sanctuary designation for the Hudson Canyon. Professor Gilbert was my incredible advisor who really made all of this possible. So big thank you to her. Okay, what is the Hudson Canyon? It is a 350-mile long submarine canyon, about 100 miles off the coast of New York City. At its deepest, it's as deep as 7 Empire State Buildings stacked on top of each other. And it supports just an incredible array of life within it and the water column above, which makes it a very popular and fertile fishing ground and for seabirds, marine mammals, and more. So in 2016, a group of advocates that was led by the Wildlife Conservation Society that runs the aquarium, among other things, asked NOAA to designate the area as a national marine sanctuary, which is one type of area-based ocean protection. So we talked in many of our MCP classes about marine protected areas, and in the United States, NOAA manages the National Marine Sanctuary Program, which is one of those ways to do it. So in 2022, NOAA accepted the designation, which really is just the start of their formal year-long process to decide whether and in what ways to implement the protection. They completed the first public comment phase, and now we're waiting for NOAA to publish a draft environmental review and a proposed management plan, which would lay out what protections apply to this area. As we all know, since the Trump administration took office, many things have been put on hold, and this is among them, where the fate of this designation remains uncertain. But that aside, if the proposed management plan and environmental review are published, then there will be a second comment period before the final decision is made about what to do with this area. So my capstone is just looking at that first piece, the submission of public comments in response to the designation. So why do we care about this? Area-based marine protection is a key part of the global call to action, which I know many of us know the UN goal is 30% of the ocean protected by 2030. So in the United States, the National Marine Sanctuary designation is a key way to do that. So my content analysis matters because understanding who supports this type of designation and why and what they're interested in can help advocates and those of us who care about the ocean to figure out how to target our scarce resources and develop support for this kind of program. So in conducting this content analysis, I started with looking at the literature. What do we know about who supports these things? What do they say? And what I found was there's a fair amount of research about the communication around marine protected areas in general, including national marine sanctuaries. And there's separate body of literature about public comments and the role of public comments in federal rulemaking. What was missing was sort of a more detailed look at who is specifically commenting on these rules and how is it impacting what's going on. So my content analysis was really to look at a little bit of that, like who are these people and what are they saying specifically? So I asked 4 research questions, which, were focused on who commented on this, what views did they express, and what sort of topics did they touch on? In NOAA's designation, they listed 8 specific content areas that they were interested in people talking about. So for my data, there were over 700 public comments submitted, and I looked at a random sample of 160 of those comments. And then I coded them. So this is just one piece of my code book, which shows, some of the definitions and how I was looking. So I looked at who are these people who are commenting, and I used the categories of commercial fisher, recreational fisher, marine recreational professional, member on behalf of an environmental advocacy group, other, or unclear. So other is someone who identified themselves but did not fall into one of those categories. Unclear, they didn't say really anything about who they were. What did I find? And why does it matter? So I'm going to just focus on a few of the key results from my analysis, although there's more, so you're always welcome to follow up and ask questions. So the first piece I just wanted to flag was my research questions didn't really ask about forum comments. So a forum comment is something that someone copies and pastes and puts into a submission for public comments. But what I noticed right away was that the impact of forum comments on all of my analysis was very strong. So of my sample of 160 comments, 100 of them were forum comments. And there were two primary types of forum comments. 90 of the 160 were submitted by what are self-identified as recreational anglers. So this is my biggest forum comment that I'm showing now, which there were 90 of in my sample of 160. And there were additional 10 forum comments that were just a generic, I support the designation. So the thing that's interesting about this forum comment in particular is that it was not in support or against the designation, but rather is sort of neutral. It just says, in essence, I will not make you read the little words on the screen, that I'm a recreational angler and you should not change the existing fishing rights of the area. Let me keep fishing. Their fishing is handled appropriately. Don't do anything else. Whatever you decide to do, NOAA, don't touch my rights or change anything. So there's much prior research, including a particular study by Costa et al. 2019, that's looked at regulated industries' role in federal rulemaking specifically. And here, this is a prime example of that. So my results were sort of consistent with what previous studies have shown, which is that people who are regulated by something tend to be the biggest amount of commenters. And we also see sort of on the flip side, people who might have a general value of an environmental good might have less incentive or call to action to comment. So here again, we see this domination of the recreational fishers. Interestingly, there were many fewer commercial fishers who participated in the rulemaking, which as we go through a little more of my results, you'll see pop up. So I'll go a little faster because I realize I'm being slow. So this is one of my response to the proposal summary. So I did a few different versions of the analysis, and Professor Gilbert helped me try to work through ways to think about this, because when the forum comments were clearly dominating, it became a little more difficult to separate like a quantitative analysis. But what we can see here is what this chart shows is who is commenting. So the commenter is on the column on the left. The top shows whether they were neutral, in support, opposed, or mixed reactions to the designation proposal. And then you can see that commercial fishers, recreational fishers are all sort of in the neutral column, although the commercial fishers, there was only 5 of them total, and 4 of the 5 opposed to the designation. So you can start to get a sense of how this fell out in terms of support and opposition. And as you might imagine, members or on behalf of environmental advocacy groups had strong support. All of them who identified in that way supported the designation. They also, interestingly, the way my analysis was conducted, the Wildlife Conservation Society bulk submitted a comment that included 13,000 signatures. So to some extent, my analysis is inaccurate, but in terms of like reflecting that full range of comments, because in theory, that one comment included 13,000 affirmations of support. So just to highlight that too is sort of a limitation of how I looked at it, which I discuss in a little more detail in my capstone analysis. Okay, and I will wrap it up there and just emphasize again that like what I saw was really consistent with what the literature said, which is that marine protected areas are hard to value and hard sometimes to communicate why Hannah, sitting in her office here in Manhattan, sorry, not with you guys, are unable to get people to come and participate and take my time to go comment on this marine protected area. So that was a key thing that I saw. Questions? I can see the room. Thank you. I so clearly explained it all. We're good to go.
I want to say, Hannah, I do a lot of stuff with waste management, and we come across similar issues with trying to get public involvement and you get basically just a few key like super interested groups, either for or against, but you're missing like most people. I think it's a common issue when we're trying to get outreach. I don't have an answer, but I think it's an area we need to work on.
Totally. Okay, well, thank you so much. It's good to see you guys virtually.
Thank you, Hannah.
Hannah.
Is Dan here?
Dan should be here, yes.
Okay.
I was gonna say, if he's not here, he's in trouble.
Okay, Dan. Dan Spanbauer is up next, aquatic invasive species, watercraft stewardship. Okay. Oh, yeah. Can I hook you up?
Oh, yeah, the mic. Yeah. Feels like it's one that I don't have yet. Oh, yeah, sure. Yeah, yes. No. Could pop it. They answered the phone straight away, so. Thank you.
Okay. Take it away.
Awesome. Hello, my name is Daniel Spanbauer, and today I'm going to be talking about my internship of being an aquatic invasive species watercraft steward. So first, just to give a little bit of background of the organizations that was a part of my program. The Capital Region Partnership for Regional Invasive Species Management, or CR PRISM, is hosted by Cornell Cooperative Extension, the CCE, which is who hired me. This organization is funded by the Department of Environmental Conservation through the Environmental Protection Fund. And this funding created the Watercraft Inspection Steward Program, which is what I was a part of for this season. So just going to a little bit of my position background, I was a boat steward at the Freeman's Bridge boat launch, which was located just right off of the Hudson or the Mohawk River. And my tasks included inspecting watercraft for aquatic invasive species, educating and engaging with the public. And then I also participated in other events with a couple of different organizations that I'll get into later. The main objectives with my position was removing invasive species from watercrafts. I would do inspections on boats and look for any types of vegetation hanging off. The most common ones I'd see would be water chestnuts, Eurasian water milfoil, and sometimes some zebra mussel. With this information, I would report this to a GIS database where I would list if there were any invasive species on boats. And I'd also list any information on where the boater was last, where they were planning on heading to go, what type of recreation they were doing, how many people they were on. And then I would also, while I was doing that, would educate boaters on proper AIS preventive methods and about invasive species as well. Since a lot of boaters surprisingly didn't really know much about the invasive species in the waters around them, or like effective ways to get rid of them. The method or the terminology we'd use is clean, drain, dry. That was kind of the message that I was constantly saying throughout the entire season of the best ways of removing invasive species off of boats, where you want to clean off the boats to get rid of any organic matter on it. You want to drain any containers that could contain water, like live wells or water in the engine. And then you want to leave them out to dry for at least 5 days, which kills any invasive species that could be on the boat. I wish I had statistics from the 2025 season that I was a part of, but we collect data until Labor Day, so we haven't released that yet. But with the 2024 program outcomes, we had 11 watercraft stewards, 11 launch locations, which this year we have 13. So you could expect the numbers to be a little bit higher. We had 11,420 watercraft inspections, over 16,000 people engaged, 820 aquatic invasive species intercepted, and we reached 1,700 new people, which really demonstrates the importance of public outreach. And another objective that I did was I participated in a bunch of additional events, which really had a large emphasis on public engagement, and a couple of them had some emphasis on field work. So the first event I was able to participate in was the 9th annual Karen B. Johnson Family Fun Day. This was a public event hosted at the Steinmetz Park, where the initial objective of it was to teach little kids how to fish. So we had a bunch of fishing rods set up that the DEC helped set up, and I helped as well. And we would give them the fishing rods and teach them how to fish in the pond, so they were aware of the types of fish that were in that area. The fish there were bluegills, pumpkin seeds, and a couple of bullhead catfish that we caught. These fish that we then caught were then displayed into tanks that it was a large event with around 1,000 people attended the event. the passerbys would come and look at the fish. And if I wasn't helping a kid like with a fishing rod or getting a worm on a hook, I'd be stationed in front of the tanks talking about the fish in the water and then holding them out so the guests could interact with them. And additionally, because I'm a part of Prism, I was able to create an invasive species tent. So in the box in the middle, that is a box full of water chestnut and Chinese mystery snails that I was easily able to find on the outskirts of the pond. That I was able to talk to a bunch of people about, not even the public, but I was able to talk to the mayor of Schenectady, the congressmen. News Channel 6 did an interview of our whole setup too. So I was able to talk to a lot of people about it, and it was a lot of fun. It was a stressful event dealing with everyone there because there was a lot of people, but it was a really great event. Another event I participated in was initially it was an electrofishing event, and then the 14th annual Great Hudson River Fish Count. So for the electrofishing event, we started idling in, it was where the Mohawk and Hudson River intersected in Waterford, and we would catch fish in nets after we incapacitated them with an electric shock. On that venture, we caught 26 different species and 150 fish total in the span of 1.76 hours of total runtime. Those fish that we then caught, not all of them were used, but they were used for the river fish count that we had the next day, where we put all those fish into tanks and the public came up and we would talk about the fish in the river. Again, I was able to set up another invasive species tent, which I'll talk about the invasives that we found, and talk about invasive species specifically. And I was able to set up my my boat steward launch setup to kind of showcase the goals of CR Prism. This was the checklist of, these are all the fish that are usually found in the Hudson and Mohawk rivers, and the check marks are the ones that we found on the electrofishing event. With the electrofishing, we found 2 different invasive species, the round goby and the common carp. Found a lot of common carp. It's, as in the name, very common. But yeah, so those are the 2 invasives we saw. We also found a rusty crayfish, which was invasive, but that was the next day, like off of the Mohawk River. So we were able to have that in our habitat as well. While we were going, I also found some water chestnut on the water that I was able to pick up and demonstrate as well. So another great opportunity to really just engage with the public and teach them about invasive species. One event that I did that directly dealt with invasive species was a water chestnut pole. So in this area, it was again in the Mohawk River. Myself and about 10 different volunteers, we went to a boat launch site that was located right off of a fire marshal's house, and the boat ramp was used for emergency vehicles to get in and out of the Mohawk to respond to any issues. But as you can see in the top right image, there's a lot of water chestnut blocking like to get to the actual river. So it was very difficult initially for them to like transfer out of there. So our task was literally to be in kayaks with plastic bags to take the water chestnut and take it out and try to create a path as best as we could in order to do that. Not only did we succeed in this and be able to create a kind of a doable path that I'll show you in the next slide, but another point of this event was the Prism needed like different events to show that water chestnut is a problem and that removing it is very difficult for human hands. So through these events, we could get funding for like water chestnut harvesters, which would be able to do the job much faster than 10 people on kayaks were to do. I'll just show you the next slide. So the top left is when we didn't start at all, and the top right was about 6 hours of work of 10 people just constantly dragging the water chestnut out. So although we did make a path, not much progress was made. So this highlights the importance of being able to have these water chestnut harvesters to remove all the water chestnut, because that Savannah water chestnut goes across miles across the Mohawk. It's in so many different areas. So it's very difficult to get rid of. So it's not the most efficient use of time to have just people do it by hand. Just go back to this slide. On the bottom right is a rusty crayfish that we saw, which is an invasive species. And then this image right here is European frogbit, which is another invasive species. But interestingly enough, we never found any European frogbit in this area. So this was the first case of it, which was pretty interesting to find. And then the bottom, this bottom image is me deconning a boat, obviously, because I was trying to do water chestnut. So I had to clean off all the water chestnut, encapsulating the image of clean, drain, and dry for CR Prism. And just a couple of concluding remarks about my internship as a whole. So CR Prism helped prevent the spread of invasive species through direct and educational methods. And what I really learned specifically is participation in events involving the public is an extremely important outreach method. Throughout my career at Stony Brook, I really only participated in like research projects or like conducting research in that regard. And I never really was able to educate the public or even interact with them. And just being able to host events, just engaging people in person, and especially involving like news media to be able to have like interviews that are published to the internet is just an extremely effective way in being able to demonstrate the message of Sierra Prism of preventing the spread of invasive species. Because at the end of the day, like the Mohawk and Hudson rivers have a ton of invasive species, but a lot of like smaller bodies of waters and lakes in the capital region are in pristine condition. And the main way invasive species can travel to those is by individual boaters carrying them on their boats, either willingly or not. So that kind of shows why it's an important method of being able to educate them and show them the problems with invasive species, how they spread and how to prevent them is very important. And then cooperation between our programs and the public helps lead to healthier ecosystems and communities. Again, with a smaller spread of invasive species causing harm to human health, the economy, and ecosystems, it's very important to limit that as much as possible. And these are my references. And then I'd like to thank my supervisor at CCE, Mr. Williams, who is the program director, and then my immediate supervisors, Alexandra Picard and Alexa Hwensky, my Stony Brook faculty mentor, Dr. David Taylor, and then finally the staff and students of SoMAS and the Marine Conservation and Policy Program. Thank you.
Okay, there's time for a question or two.
Yeah.
What was the willingness of people to talk to you at the boat ramps? Because my experience with those things is that people are always shouting at each other
Yeah.
to get their boats out quick so the next boat can go in. So
Yeah, no, so I mean one method that we were taught was that you want to keep it as short as possible. So like the inspection process takes about like 2 to 3 minutes. Lucky for me, most of the people were pretty like kind and they were willing to let me inspect their boats.
Yeah.
But yeah, definitely occasionally there were people that would either not be willing to or even just like completely say like, no, you can't inspect my boat. I've had someone when I'm inspecting it just like drive away from me in the middle of it. So but that was kind of just another challenge with my job is just kind of finding that balance of like interactions with the public. So I can either, if someone's willing for an inspection, I can talk to them freely about the problems with invasive species. And there's someone else who's grumpy and just wants to get on the water. I kind of just inspect their boat and kind of let them get on their way.
Yeah.
So you kind of find that balance on the spot.
Cool.
Well, I have a question. So if you could do this over again, what would you do to improve? Thanks.
I guess my first, I would honestly, so for some of the events, one event I didn't talk about was I did a tabling event at one of the local fairs in upstate. And although it was like, there was a lot of like information, not just on my program, but a bunch of programs within CR Prism. There wasn't really any like materials to give out to the public or really effective ways to engage with them. It was just like information. So on my launch site, I have like DEC towels, I have floating capsules, stickers, and that kind of stuff that kind of attracts the public to my tent too. So really just kind of distributing more of those materials, I feel like is a really effective way of just initially grasping people's attention. And then with that, you can kind of introduce your program and like what you're all about. So kind of just emphasizing stuff like that.
Give out free stuff.
Giving out, people love free stuff, so.
Okay. Thank you. We need to, yeah. Maybe.
Thank you.
Yeah, let's figure it out.
Okay. Next speaker is Catherine Weglars, and her topic is applying science communication techniques in shellfish restoration policy. There you go. Looks good.
Okay. Hello, everyone. Thank you so much for coming out. My project was on science communication for shellfish restoration policy. My name is Catherine Weglars, and you're probably all relieved to be in the W's now because that means that you're in the home stretch. So over the summer, I worked as an intern for the town of Oyster Bay. It's a local municipality that stretches from Oyster Bay, the town itself, down to Massapequa. And this is especially near and dear to my heart because I actually live in the town of Oyster Bay in Massapequa, and I've spent my whole life on the water. So protecting the water in my home community has just been such a pleasure and a joy, and I'm so grateful for the opportunity. So I know a lot of you in SoMAS and maybe in fisheries management too might have heard a little bit about the Frank M. Flowers, that whole leased land operation. And for those of you who aren't familiar, essentially the town of Oyster Bay up in Cold Spring Harbor and Oyster Bay Harbor used to lease out underwater lands to the Frank M. Flowers Shellfishing Corporation. And they leased that out for a very long time. The leases last about 30 years each. So basically, until that lease expires, the township unfortunately couldn't go in and evaluate how many oysters or clams or any kind of shellfish for that matter were left over, or the sediment quality, which left a lot of unanswered questions about the state of the shellfish in the harbor. So you can see that's me. They caught me quite unawares when they told me to come out to the hatchery and take these pictures. So I was wearing some nice clothes and I was not prepared to go into the flupsies. But on the right-hand side, you can see the start of the summer. Those are our oysters, and they kind of look like sand or pebbles because they really were that size, and very rapidly, in about a month, that's how they grew out to. And at that point, they were out in our floating docks or flupsies. From our nurseries. So shellfish are important. They're important both to the community and to the environment. They're an important food source, not just for humans. Of course, we all love our oysters and clams, but they're also for, animals in the harbor. They're also amazing at filtration. The oysters in our harbor can filter up to 50 gallons a day, each one of them, which is really incredible. They're also important to researchers. There have been SoMAS faculty and a Delphi faculty as well, I believe, that have worked in tandem with the town of Oyster Bay to see what's going on in the state of the harbor, especially with shellfish. And of course, there's shellfishing livelihoods and recreation. A lot of the baymen rely on shellfish to sell it either direct to consumer or to businesses, and that's a critical part of the local community. Okay, so in the scope of this project, there are some important definitions to remember. So the first one, which was the current one over the summer, was the conservation management areas. So the town of Oyster Bay, following the Frank Flowers lease expiring, put a moratorium on shellfishing, and they established conservation management areas. And they were not defined by law, and each one of them had specific instructions on whether or not you could harvest there, whether you couldn't harvest there, whether you can plant shellfish there. So it wasn't very closely defined, but it was more of an emergency action just to take initiative. And the marine management areas are legally defined. Both the marine management areas and the shellfish sanctuary areas were passed under law and town code. And they were passed in the same town code. So marine management areas are legally defined as a general area for marine conservation. Shellfish harvesting is banned in these areas, but seeding and planting is not explicitly permitted. So it's not banned in these areas, but it doesn't give permission to seed there in the first place. Any uncertified waters within Oyster Bay's jurisdiction automatically get this designation now that that town code has been passed, which is wonderful because that means they've just automatically been designated to be protected and the wildlife within there. Shellfish sanctuary areas are similar, but their protections are specific to shellfish. It's in the name. And shellfish harvesting is also banned, but this one does give permission to seed and plant shellfish. Uncertified waters are not automatically designated, so that's another important distinction. But when you give the designations to both of the designations to one area, that results in overlapping protections for shellfish and marine life alike. So my role in this project, this was a ongoing thing, not just with the Frank M. Flowers lease expiring in the moratorium. This was also ongoing with SoMAS faculty conducting research, lots of stakeholder meetings, applying this new town code, and various other operations. So my role was the very end, the finish line, in drafting a memorandum. So in the town of Oyster Bay, in order to pass a new resolution, you need to write a memorandum to submit to the town board, which is a group of 6 elected officials with a town supervisor presiding over it. The current town supervisor is Joseph Saladino. The town board votes on any memorandums or proposed resolutions. So it's very important to draft a detailed and accurate yet digestible memorandum so it translates into science, but also policy. So the goal of the memorandum was to pass a resolution to establish new marine management areas and shellfish sanctuary areas to advance the town of Oyster Bay's existing shellfish restoration efforts. So this would include the already defined conservation management areas that had more fluid, I would say, restrictions, and this would overtake them, and these new definitions would take place instead. So I utilized science communication and writing to draft a memorandum for the town board to review and eventually vote on. So I reviewed and researched a couple of science communication methods, and the 2 that really stuck out were lay expertise and contextual. So the lay expertise method values the knowledge and lived experiences of the audience and community equally to the knowledge of scientists. So this means that it's not just audience members like you and me. This means that it would also value members of the community, laymen. In this case, that would be the baymen and the shellfishers that rely on this for their livelihoods and work out there every single day and see the state of the harbors. When you use lay expertise, you have to be mindful to avoid straying too far from accredited scientific findings, because you do place equal value from lived experiences to science. So you have to be mindful that you're not straying too far away from science. And an example of this that I observed in a stakeholder meeting with my supervisor, Sarah, was when one of the stakeholders in the meeting, he was not a scientist, he was not a policymaker, but he was just a regular layman who worked in the harbors. He was curious to see why we had made a certain decision to put out a certain size of clams rather than larger or smaller. So we used a familiar concept. Fecundity, and when fishermen catch something that's too big or too small, they have to throw it back. So we use that concept to kind of explain that it's similar for when you plant out oysters and clams, that you have to stay within a certain set of guidelines to promote the health of the shellfish in the harbor. And the contextual method acknowledges that social issues in a community may influence the audience's perception of the science communicated. So the town board would care about how the policy would affect their constituents. So that's how it would be reflective. So in the memorandum, I utilized contextual to show how shellfish restoration remains a priority for the department. So instead, we had thought about using a couple different pieces of information or science to communicate to them, but unfortunately the memorandum can only be so long, and when you're talking to policy members, you also want to try and keep their attention. So we decided, instead of talking about the amount of oysters and clams that we had already outplanted in the existing management zones, to talk about how it could be beneficial to the constituents of the town of Oyster Bay. So we wrote, shellfish restoration remains a top priority for the department, as recent surveys consistent with trends observed in other Long Island embayments indicate significant declines in shellfish standing stock, seed populations, and harvest levels. And we also said shellfish play a critical role in the estuary, providing natural water filtration, mitigating harmful algal blooms, and supporting as a vital habitat for fish and waterfowl. And on the right-hand side, it was just a little bit of extra context for you guys to see that this is relevant to the town board because they actually passed in town code that they acknowledge that shellfish are important for public health and welfare, water quality, and the livelihoods of the baymen. So for lay expertise in the memorandum, we just wrote a little bit about how the selection process was informed by scientists. So for example, SoMAS faculty, a Delphi scientist conducting research, by the Department of Environmental Resources in the town of Oyster Bay. We had an environmental review study performed by Cash and Associates to make sure that the sediment quality was could work with shellfish restoration. And we also worked with the baymen because their livelihoods depend on it and it's of interest to them. And we wanted them to be included in the discussion. And we also value their input. They're heavily respected members of the community. They provide a lot of food to small businesses as well as just the population in general. As a Town of Oyster Bay community member, I can very much tell you that the baymen are loved and respected by everybody living there. And it was great to be able to include their input. And I'm happy to report that the resolution recently passed in the town board just last week. And the sanctuary areas will be established. And I learned a lot about the value of choosing science communication methodology based upon your audience. Lay expertise was key here. Like I said, the baymen are highly respected. And of course, there's value in creating new shellfish restoration models, as this can not only positively impact the local marine ecosystem, but serve as a model for future shellfish restoration efforts. We also use previous shellfish restoration efforts, even ones that SoMAS has been involved with, like Shinnecock Bay, as a model for this. And, you know, it really helps demonstrate to not just other scientists, but the general public that when people band together and when you use science communication to bring different people together and create an informed population, that it can turn the tide on whether a story about shellfish population or any other marine conservation effort becomes a cautionary tale or an inspiring story. Thank you all so much for listening. Are there any questions?
Yeah.
Thank you so much. I'm very excited. I feel very fortunate. This was a culmination, as you could see, of a lot of work. I mean, even just other laws had to be passed just for context for this one to be passed. And I'm very grateful that my supervisors trusted me with writing this memorandum because it was the final step. And it's exciting. We're hoping to see that the health of the harbor improves.
Other questions? Okay, thank you for that inspiring talk.
I was gonna ask, what's the hardest part about, so we talk about science-informed policy all the time, but not many of us write policy. So how did that, like, what did you find the most challenging in doing that?
I think honestly, the most challenging was trying to differentiate between, because I had communicated in the past science to my peers, obviously in the MCP program, who understand a little bit about marine sciences or a lot about marine sciences already, but also just the general public. And it's a little bit different when you have to communicate it to policy members because it needs to include enough information to substantiate creating policy, but also not jargon so that you can keep their attention. And make sure that they understand what you're talking about. So it was a little bit difficult to strike that balance, which is why I thought that contextual was great instead of just talking about the other management areas' previous success, because what matters to them at their core, I realize, is what would make their constituents happy and also what would get them reelected. And if they see that the townspeople are happy, they're more inclined to probably vote yes. Yeah. Okay. Thank you.
Thanks.
As a former W, I really should have done this in reverse and put the W's first.
You know, that would have been decent of you.
Next year.
There you go. I got it. Oh, okay. Oops. All right, so not too much now. There you go. All right, so I'll have an apply here there. Okay, so go away. So just advance in usual fashion here.
Yeah.
Okay.
So last but not least.
We'll see, right?
Yeah. Okay, Pat Wiedenkeller, understanding and improving water quality in Setauket Harbor.
Yeah.
And I was fortunate to be her faculty mentor.
Yeah.
And her internship supervisor is Molly Graffam from Cornell Cooperative Extension.
There.
Raise your hand.
There she is.
Hi there.
I just advanced like here.
Yeah.
Yeah, okay. All right. Thank you for being bitter enders. Appreciate it. So measuring nitrogen inputs in pore water, surface water, and groundwater seepage in Setauket Harbor sounds pretty sexy. It's
Great headline.
It's the very interesting project I've been part of as an intern with Cornell Cooperative Extension of Suffolk County. And why the work is so, I wanted to talk about why the work is so important to on the ground understanding of how to maintain and hopefully restore the health of Suffolk County's surface waters, maybe one water body at a time. Our little piece of this is a cove, a tidal creek that you see here at the headwaters of Setauket Harbor, Setauket Tidal Creek. To orient you, here's a pullback. Let's see, our section, here's our, it's, sorry, nervous already, on our section of the North Shore of Suffolk County, this little section. So you can see there's us at Stony Brook, and then the little circle there is Tidal Creek. This is a closer look at the creek, and you can see it's moderately populated, and on the main street to the south, there are businesses too. This is a picture of Setauket Harbor at 5 a.m. in the morning, 5 a.m. It is in the morning, on my first day on the job in June. The early hour was to take advantage of low tide. We were there to conduct water sampling over two-week periods in June and August to find out how so much nitrogen was getting into Setauket Harbor via submarine groundwater discharge, or SGD. SGD happens when groundwater flows more or less laterally from the aquifer that's beneath our feet, from higher elevations toward the shore. It seeps into local water bodies, and if it is dragging excessive nitrogen or other pollutants, can damage the marine system. Nitrogen is an essential nutrient in local waters. A normal healthy amount coming in would be around 1 milligram per liter. That's roughly what it was in the upper glacial back in the day as native groundwater before development. But excessive nitrogen from SGD is a bad thing, as we all know. Some people talked earlier about this. There's eutrophication, algae blooms could go to hypoxia, fish kills, and other things too horrible to mention. So in Suffolk, nitrogen pollution comes from different places: agriculture, fertilizer on golf courses and your lawn, pets, but far and away the biggest source is nitrogen carried in SGD from backyard cesspools and septic systems. Suffolk is infamous for this. There are amazingly some 360,000 cesspools / septic systems still in use in Suffolk County. They don't remove nitrogen. And not much sewering here as an alternative. Suffolk is a real outlier nationwide and not in a good way. The rate of SGD discharge into surface waters is variable and site-specific. It's based on localized sediment composition in the aquifer, tide cycles, fertilizing past and present, and so on. SGD can be carrying waste from months, years, decades ago that's finally making its way from the interior to the shore. They call this legacy nitrogen, and that makes it sound very special, but it's really not a good thing. Suffolk County has an amazingly thorough sub-watershed wastewater plan with these great models predicting nitrogen flow to water bodies all over Suffolk County, including Setauket Harbor that you see here. But as far as anyone knows, no one has directly measured nitrogen inputs into the harbor, where it's coming in, how much, and how fast it's traveling. So mapping, characterizing the SGD zones, ranking them for nitrogen loading, mapping them within the water body, adds new knowledge about nitrogen in this area that's not available in the models, a baseline from which to make actionable recommendations on how to reduce it. That's the goal. That's the why. Onto the project. So you can see the plan here, testing over 4 transects spanning the cove, evaluation of 8 stations per transect with 3 pore water samples collected in each transect. And stations along the shoreline, you can see between the transects, where pore water was also sampled. And here in the center, you can see the blue sampling areas for surface waters. So the premise is that stations that show high groundwater flow and elevated pore water nitrogen concentration over the 2 seasons are the stations that contribute the highest nitrogen loading to the surface water as a whole. Here is a graph of the daily water levels we were working with, pretty much a 6 or 7 foot range from high to low tide in the June testing period. Our sampling window was 3 hours before and 3 hours after low tide. On a practical level, you can see the difference that the tide swing makes when you're trying to sample here. So you're going in there in very muddy conditions, but the water is, not in the harbor so much. And then you're trying to beat it out of there before you drown. And here's the big muddy at dead low, when you can see how exposed the creek bed is. And it's another advantage to testing here. We can make observations about conditions. We can see where the groundwater is trickling in over the sediment. We can see, ribbed mussel banks, natural ribbed mussel banks. We can see really big clumps of oysters, really big oysters, and all of it is context to the studying the conditions there. So these were our methods. We were taking field parameters of the pore water and surface water. We were taking GPS locations. You can see it on the right, Molly doing that, so that we could go back to the same locations in August that we had visited in June. We were collecting pore water with the piezometer setup on the left there. The piezometer has a screen that gets driven into the sediment, which allows us to collect samples and alert the community that we're there. You have to hammer it in. We took readings from this water and the surface water for, among other things, temperature, conductivity, pH, dissolved oxygen. We took cores using a rigid, clear plastic tube pressed into the sediment, and then characterized it in the field. On the left, a sediment core of coarse, gravelly, sandy sediment, which would usually indicate faster groundwater flow. But we also found areas like the photo on the right that were silty and mucky and organic. And this kind of area, we would not expect so much groundwater flow. Seepage meters were set in 3 to 5 stations per season. They're measuring the flow of water seeping up into the surface water, direct measurements of that flow rate in milliliters per minute. And here are the seepage meter stations where they were put out around the cove. So these data all provide information to the study area and this water that's unique to the study area and to this water body. So results, they are underway. We're now in the second round of testing, and we'll need the labs and then to input it into Excel and make the data, that is, and make calculations on those. But we have a few preliminary maps on some of the data from June. Here's a map of pore water nitrate from that period. The red dots indicate highest nitrate concentrations greater than 6 milligrams per liter. The peachy dots are from 2 to 6 milligrams per liter, and the gray dots less than 2 milligrams per liter. Again, the values for clean, non-polluted water would be expected at 1 milligram per liter or less. We didn't, only 2 of the stations showed a low value like that. So most stations had the moderate range, 2 to 6, and several hotspots you can see on the left, on the western shore, that were over 6 milligrams per liter. And there's one down below on the right, on the eastern shore, behind a kayak shop, and then there's another one up in the Phragmites. Let's see, here's pore water, TKN, which is the sum of organic nitrogen and ammonia nitrogen. and a possible indicator of the presence of untreated wastewater, such as from cesspool effluent. Fewer areas here with high levels, but the ones that are tend to overlap, you see on the western shore with the high nitrate levels. So what next? We got to process the August data and see what else it says. And then prepare the deliverables for this project to share with the Setauket Harbor Task Force, the partner in this project. And then produce maps of showing nitrogen loading in Setauket Tidal Creek, and a narrative report, including recommendations for remediation spots within and up gradient of the cove, and also a presentation. It's meant to educate and provide guidance to lawmakers, policy makers, and the community, basically. The data and photos will also be publicly available for review and use. So what could remediation involve? Theoretically, new sewering would be where possible, although I don't think that's in the cards. That's a really big ask. It could be incentivizing homeowners and businesses to replace cesspools with innovative alternative on-site wastewater treatment systems, little below ground units that are much more effective at removing nitrogen from wastewater than cesspools, which don't. Last year, nearly 72% of Suffolk voters approved a proposition to raise the sales tax by 1/8 of a penny to fund countywide wastewater improvement projects. So the county and also the state are offering really generous reimbursements if you put in one of these, and voters saw the need. So here's an array of the models. I'm not sure if all of these are on offer right now, but a lot of them are approved for installation, including the one that I have in my yard, which is the Fuji Clean in the middle on the bottom. The reimbursement basically covers the whole cost, though installing them can upend your backyard for a while. It's kind of worth it. Remediation could also be siting where suitable permeable reactive barriers. Here's a cartoon showing roughly how they work. They are subsurface walls or column arrays or the like containing a carbon source like wood chips or vegetable oil. They're designed to intercept and treat often big SGD traveling over a wider area. This could be legacy nitrogen, for example, that's non-point source, to remove it before it reaches the surface waters, with an acceptable byproduct on the other side of the barrier of harmless nitrogen gas when everything's working well. PRBs are passive, highly effective when they're well placed, very site specific, and can potentially remove up to 100% of nitrate, which is a lot of percent. And figuring out whether to site one in the Setauket Harbor area would mean putting in wells for starters to home in on the SGD flow in prospective areas. Another thing could be bioextraction of nitrogen, including with kelp farming, which the Setauket Harbor Task Force has successfully done in a pilot program, and that's another potential recommendation. Kelp sucks up the nitrogen and the CO2 also. And the CCE team will be laying out options like these, perhaps for stakeholders, including property owners. And it could be tricky, as we know, some property owners would have to be persuaded by the data to do something very different in their yard or their community, even if they love their local water body. And that's where testing like this is so important. It's not conducted at 3,000 feet or by AI. It's collected on the ground. People running around in the water body in the morning, people stopping and saying, "What are you doing?" And you tell them, and you get community buy-in. And that's kind of the point. It's scientists are collecting it and they're helpers, and it's tested in the lab, analyzed. It's custom data. Scientists bringing the receipts, and they offer the first step in abating the nitrate load in this beautiful harbor. And that's the good news. Nitrogen is something that we can control. So that's a big positive and good reason for optimism. So I wanted to thank, that's all of it, thank you. But I'd like to thank Dr. Molly Graffam, who took me on as an intern and is both brilliant and patient and kind. And the CCE field technicians Joe Costanzo and Stephen Havens, who are funny and incredibly smart guys who can MacGyver anything and nothing flat if that equipment or process isn't working. And before I got my mud legs, they pulled me out of the mud a lot. And it was really a privilege to muck around with these people. I learned so much. And I also want to thank Dr. Matt Sclafani for connecting me with Molly. And of course, my faculty mentor, Dr. Ellen Pikitch, who's helped me find my way into this great program, for which I'm very grateful. And questions? Yes.
So if we remediate with kelp in the harbor, where's the kelp go? What's the fate of the kelp?
You can eat it.
What?
You can eat it.
Oh.
Yeah, that's the word on the street. When I read about it.
Okay, did you like it?
I haven't eaten any of it. I mean, in restaurants, I've eaten kelp-like things, but yeah, I mean, when I was reading about the Setauket Harbor Task Force's project, that was one of the things. I'm not sure that they were selling it to restaurants. I don't really know, but I think you can eat it. That was
also not burning it, because then the carbon's just going right back. Yeah.
What would be the point of that? Yes. Maybe fertilizers. Nothing else? All right then. Thank you for.
Okay, well, it's been a long but very interesting day. And thank you all for coming. I'd like to ask all of the people who presented to come up and let's get a photo in the front.
I gotta do it. And then we need